Testing 1 2 3, testing 1 2 3. Start with the wait, guys. Testing 1 2 3. Yo, what's up? Welcome back to Vencabot. Intro to Python action. My name is David. We're doing some intro level tutorials for Python here every Friday at around this time. A little bit late today, quite a bit late actually. As things to take care of before the stream I didn't expect to have to do, but we're all wrapped up now, I believe. We can get the show on the road here. Every season of Intro to Python is 6 episodes, and every season we work on a different kind of project. So we've got. Right now we have this virtual pet we're working on. It's sort of like a Tamagotchi, sort of like a little miniature game where you feed a pet and you can play with it. It's not that interesting as a game, but I think as a example for all these ideas we're putting forward, it's pretty decent. It's pretty fun, I think. One more good vibe. Patrons is the dude. So me and Hugo's talking about our other game we played, Third Strike, Street Fighter 3, where he thinks that some guy has found a way to exploit the game. We're kind of discussing that here, but I'm going to probably change gears, looking more at Python right now. Keep that in mind, though. Here goes. Patrons with a Y and a Z. That's interesting to me. I've never met this guy before, but if it's true that he has a way to exploit the game, that'd be pretty interesting, to say the very least. I might try some experiments, see if I can replicate it. So I have a theory that by tapping the home button twice, you might be able to do it. It might work. So where are we at in our game right now? Well, last time we talked about function definitions, right? And about how previously we'd been working in our code more or less straight down top to bottom. Right, more or less, with some deviations, right? We have, in our original code, we had these while loops that would cause code to run sometimes from top to bottom and back to top, right? But more or less, we had code that sort of ran top to bottom. But now that we're introducing function definitions, we're able to break up our code into these little blocks called functions. Right? These little blocks here, where when you call this function, feed pet, anywhere in your code, it runs this code. Right. So by doing that, we're able to break up our code into little segments that are individually functional. Right? We have this entire little program here, this little sub-program where you can feed the pet. Here we have a little sub-program where you can play with the pet. Right. And then down here we have our main code, the code of the actual program itself, which kind of just runs along. Right. So last time we talked about that and about arguments and return values, which can get a little bit complicated. Again, we're in episode 4 now of a 6-episode series, so it's not quite as beginner-centric as it was, not like total beginner first-time programming kind of thing, but it's a little bit involved. We have these calls right here to our functions, right? And as you can see, it takes a lot of these little bits of data between the parentheses. Whenever you call a function, you use its name, feedPet. We named that function feedPet. You follow by parentheses, here and here, and then between the parentheses you put a comma-separated list of data, right? Like pet's name, pet's happiness, pet's hunger, right? We feed it these 3 bits of data so that the function can do its job correctly, right? That's kind of where we're at right now. And then the function can return a value, right? And it can give you a value back once it's done doing its job. In this case, we feed the pet with this data, the pet's name, its pet's happiness, and its pet's hunger, and then the value we get back is the new values, right? We get some new values back, like whether or not we fed the pet rocks, true or false, the Boolean value. Whether or not the pet is, how happy the pet is, and how hungry the pet still is afterward. That's kind of what happens after we run feed pet. It gives us this data back. Whether or not we fed the pet rocks, how happy the pet is, and how hungry the pet is after we just fed it. It returns that data as a tuple. I talked very briefly about tuples last time. It's a new data type for us. And a tuple is just a single piece of data that contains several other pieces of data sort of enveloped inside of it. Right, so here we access the bits of data in this tuple by their index number. 0 is the first index, 1 is the second index, and 2 is the third index. Right, so basically we have this tuple here that has 3 pieces of data in it, and they're organized 1, 2, 3, or to be more accurate, 0, 1, 2. And we're getting the data out one at a time and kind of assigning these new names to pieces of data, right? That's really all there is to it. Tuples is sort of like a bunch of data crammed into one. Hugo says, you missed a segue to shill your Patreon. I considered it, but I was like, no, it's too low-hanging fruit. Good Vibe says, I'll try. I'll be on and off lurking until Liberal Crime Squad. Are you playing that in 2 hours or 3? I haven't really decided yet, Good Vibe. I haven't decided. I really was not expecting to get started so late today. I'm not sure if I'm going to run this show a little bit late, or if I'm going to even get around to playing Liberal Crime Squad. I would love to. I think I probably will, but I'm not sure what that means for Minecraft or when this is going to end exactly. I'm going to have to decide as the stream goes on, Good Vibe. I apologize about that. The lack of clarity. Okay, so, yeah, so here's our main loop. This is where we have our unindented code. As you guys know, any line that is not indented is run in order top to bottom, right? And then we have these code blocks, which are indented, and they are run conditionally. They will only run under certain circumstances, and sometimes they won't run at all. right? If the circumstance is not true. Other times they'll run more than once, right? Such as while here. So very quickly, let's go through our code, see how it works. And we have, again, all the left-aligned lines are always run. So we're defining this function. This line is run. We define the function, we give it a name and what it takes. But this code here is indented. That's a code block. That means this code is only run conditionally. And the condition is we have to call the function. So this code will not run right now. We start at the top of the program, we define the function, and then this code just waits to be called. So next thing we do is go down here and define this function. Again, fully left aligned, right? Play with pet. So we define another function. Again, this indented code here is the code the function will run conditionally. And that condition is when the function is called. Right? Otherwise, it won't run. You have to call the function to make it run. Here we have more left-aligned text. You know, there's no indent here. This code will run straight top to bottom. So we define some values here. Pet's favorite foods 1 and 2. The pet's hated food, which are all strings. That's textual data. You can tell that because of the quotation marks here and here. Then here we have a couple of integers, you know, numerical data, pet's happiness and pet's hunger. These values are numerical, so we can do math to them, right? Certain things happen in the game, make happiness go up and down, and hunger go up and down. So as our program advances along, these numbers are going to have math done to them. I'm sorry, I smacked the mic. Here we have a Boolean value, right? Another kind of value we talked about, which is poop on floor. Booleans are true or false values, right? So we've got strings, which are text. We've got integers, which are numbers you can do math on. Then we have these Booleans, true or false values. Here we have poop on floor. That is false. So at the start of our game, there is no poop on the floor. But as our pet is fed, it will poop. It'll be poop on floor will be true. Hey, what's up, Jose? David! Jose! So after this, we run our first function call. Well, you're right, Mr. Part 2. If you run for people, you run into something worse. That's very true. I've learned that the hard way. Yeah, that's something that I think not a lot of people realize. Right? I think a lot of guys go their whole lives, and I may yet go my whole life, you know, in times believing that you can kind of get away from people, and that's something that's, you know, reasonable to do. It's reasonable to want to do that for sure, but what I found is that if you do that, it's not a way to make yourself happy. Okay, so we have this function here, right? This input function. Now this one's glowing in our idle IDE, the Integrated Development Environment, right? So it's kind of like Notepad. This whole program here, idle, is exactly like Notepad. In fact, all it really does is highlight things so that we can kind of see what's going on in our program a little bit easier, right? And here we have input and print are highlighted a certain color. That's because they're built-in functions in Python. These are not functions that we made, but they are still functions. They're just the ones that come with Python. So input is one that takes one argument between the parentheses, which is the prompt to show the user what is your pet's name. And then it returns a value, which is what the user typed in before they pressed enter. Right? So if I says here, what's your name? I type in, you know, Jose and press enter, then pet's name becomes equal to the string Jose. Right? Then we print off a blank line. If you call the print function, print built-in function, with no arguments, right here, it's a, you know, empty parentheses, that means that you get a blank line. Jose's a pet. Dude, I used to be a pet. I used to have a really kinky ex-girlfriend. So we have this while loop, right? So this is another code block, right? So these, we talked before about how these functions are code blocks. They only run conditionally, right? And the condition is you have to call the function, right? Here's another code block. So the while part is not indented. So this line is always run, right? And it asks Python a question. Is the part after while true? Right? We could say, for instance, while pet's name is equivalent to Jose, then run this line of code, right? Run this code block. So it's a condition, right? Code blocks always run conditionally, and the first line where you define the code block is run, and it asks Python a question, right? Is this second part true? And in this case, because we typed in Jose up here, hypothetically speaking, we didn't literally do it, we talked about that, right? We put in Jose for the pet's name. If we did, this code would run, right? So that would be the condition for this while block. However, we had it set as true. Right? There is no question. Hope you didn't let all the chun talk, chumbius get to you. Harsimus, it was a little bit stressful, right? I don't feel great about the fact that Krim feels hurt by the way that he sees himself as being persecuted on the stream. I don't feel great about that. As for the Chun BS, it's whatever. I've definitely heard all that before. I said, not everyone's going to agree with my feelings about Chun. Right? I totally understand that. But this is how I feel about Chun. Thank you, Harsmus. So at the same time, people that disagree with my feelings about Chun, I mean, they're not villains or anything. They just feel a certain way about the game, just like I do. But thank you for your support, man. I respect anyone that loves and plays Third Strike. I don't care if they play Chun or whoever they play. If they play Gil, whatever. I'm not going to like it, but, you know, they're still, you know, human beings, to the very least. All right, so we have this while true block, right? And the second part here is a condition, but it's just true. There's no question. There's no question being asked to Python. Just always run this block, right? It says while true. Just run it. Right? Because the second part has to be true for it to run. Well, it's literally just true, so it's going to run. Right? Here we have some more code blocks, right? They're questions, right? If not poop on floor, then do this. So the not keyword will invert a Boolean value. Sounds kind of complicated, right? Basically what we're saying here is usually if says, if the following part after if is true, then run the code block. Right? In this case, this is true because the following part after if is not poop on floor. Well, poop on floor is false. Right? Poop on floor is false, so not poop on floor is true. So this will run if there is no poop on the floor. I think something that I felt with the lobby system and your stream is that I wish there were more mod-type people that organize side lobbies. I totally agree, Hars. That would be nice, but it's very hard to coordinate. That's something I've dreamt of myself, Hars. It would be really cool if we could get, like, not only, you know, 1 or 2 lobbies, but what if, you know, we could one day have, you know, countless players in the Third Strike online PS4 scene that, you know, when it became that time of night, it was just blowing up. Right? That's the time where everybody gets together and plays PS4 Third Strike, you know? 10 lobbies, 20 lobbies. That's the dream. But I think a lot of people are not interested in playing if they don't get to play on stream. I'm not sure what I guess they like the commentary, which it makes sense to me, right? I think the coaching's kind of a cool feature of the stream. At the same time, it just seems kind of weird to me sometimes when people want to play on stream and we have a full lobby, so it just can't be done. But then they don't want to play after that. They don't want to play in their own lobbies or, you know, keep the game alive in that respect. But it's whatever. And I'm sorry, guys. Talking about Third Strike here. Said me and Hars are Third Strike players, along with me and Here Goes, and lots of other guys in the chat. Jose, this is part 2. Okay, so we have this, you know, little code block here. We have a couple of code blocks inside of this code block, right? If and else. You know, else will run this code conditionally if the first part does not run, right? So if the if does not run, then else will run. Yeah, I think I'll think more on that and put some thoughts on Discord. Thank you, Hars. Yeah, that'd be really sick. We have this pet activity. You know, the if pet activity is feed. So basically what we're saying here is that we have this input line, right? Pet activity. And whatever the user types in, because of the input function, is saved to this name, pet activity. Then we're going through this big list of if and elif blocks to figure out what the user typed in and what to do based on what they typed in. Right? If they wanted to feed the pet, we run this code for feeding the pet. Right? If they wanted to play with the pet, well, we run this code here for playing with the pet. It's kind of the idea, right? So the user types in what they want to do, and then our code goes through all the possible, you know, things they might have typed in, and then says, well, if they typed in this, then do this. Otherwise, if it was this, then do that. And so on and so forth. That's all this code really does, right? All this code here, all these lines that say, if pet activity equals, you know, so if it's equivalent to, that's just testing what the user typed in and doing the right thing based on what they typed in. Right? So I'll write down to here. So these are all of our options I can type in, right? Let's go look at these. So here, we can feed our pet, right? If they typed in feed, then do this. We can play with the pet. If they typed in play, then do this. We can quit the game. If they typed in quit, then do this. If they typed in clean, to clean up after the pet, right? We run this, right? If they poop on the floor, then we clean it up. Otherwise, there's nothing to clean. Right? If they want to type in dagger, it's our cheat code, right? Dagger is a cheat code that gives you a bunch of happiness. So if they punched in dagger, we'll then run this code here. Max out the happiness, or at least put it to 100. And we have this little else block at the end. So, to say if, elif, else, right? Here it is. If, and then an elif, and then an elif, and then an elif. What we're saying here is, if this is true, if they want to feed their pet, then run this code. Elif means otherwise, if that wasn't true, but this next thing is true, then run this. Right, so let's translate that, right? If the pet activity is equivalent to feed, run this. Otherwise, if pet activity is equivalent to play, then run this. Otherwise, if pet activity is equal to quit, then run this. Otherwise, if pet activity is clean, then run this. And finally, otherwise, if the pet activity is equal to dagger, then run this. And then this else just means otherwise, right? So here we have elif, otherwise if this, do this. This just says otherwise, print off, please either feed or play with pet's name, or clean or quit, right? So what it's saying here is, if they typed in something that didn't match anything above, then just tell them what they can type in, right? Please make sure you feed or play with the pet, or whatever, right? Then we have, at the end of this code, after we've done finding out what the player has done, right? The player has picked their option and done something, right? Then we have these few lines down here within the while loop that always run. It says here, if the pet's hunger, after all that shit we just did, if it's still greater than 70, then print off the pet seems kind of hungry and make them less happy, right? They're hungry, they're not as happy. Indeed I do, Harsh, I'll tell you why. So we have this, and after that we do, well, is there poop on the floor? If after all we've done, there's poop on the floor, then again, reduce the pet's happiness by a little bit. Right? So at the end of our turn, essentially, if there's poop on the floor, the pet becomes less happy. And then finally, if after all this, the pet's happiness is less than or equal to 0, so it's pretty much at 0, it's at minimum, then print off the pet bits you, and then the game's over. Right? Break. So what Harsh asks here is, do you need continue in that else? Jose says, I feel like I'm in school, I feel like I should be learning. This makes me want to learn. I think that learning programming is an awesome skill to learn in the year 2019. It's very important. I feel as we interface more and more with computers, you know, in our pockets, you know, at our jobs, at home, I think that it's really cool to be able to write software for these programs and make them do what you want them to do. I also think that it's also a really creative hobby. It's a good way to kind of get your creative wiggles out. So let's talk about continue and break. Right? These are one-line keywords in Python that interact with a loop, whether it be a while loop like the one that we're in right now, or a for loop, which we're going to learn about today. Right? There's pretty much two kinds of loops in Python. There's while loops and there's for loops. We're looking at a while loop right now. Basically, if you see the word, the command break in a loop, it will forcibly end the loop. And because our while loop is going to go on while true, it's not some value that we can change over time. Right? It's not going to be like, if pet's happiness is greater than 50. Right? This will cause our loop to end if it reaches the bottom, and when it goes back to the top and checks again if it's still true, this is no longer true. So in our program, our happiness might change a lot, right? If it's above 50, well then it's going to keep running. If it's below 50 or 50 even, it's going to end the loop. Right? However, in our case, that's how you end a loop naturally. Right? In our case, though, we have this while true. It's going to never stop running because true is always going to be true. Right? There is no condition there. It's just true. And for that reason, the only way to end this loop is to do it unnaturally, which is to forcibly break out of it, right? Using the break command. So here we see we run break when you try and quit the game. Right? If the player wants to quit the game, print off Jose goes back to bed, and then break. Break means end the loop right now. So we just jump right down to the bottom of the loop, and we get out of it. Boom. Game over, it says. Right? After we get out of the loop, we print game over. Also, we get this break command after the pet bites you. That's game over. Right? So when the pet bites you, it ends the loop forcibly. Break right there. Game over. What's up, Black? Said, hello, science guy. Yeah, Black, got your message on Twitch, man. I'm going to add you on Facebook when the stream's over. I'm looking forward to that. Okay, so we also have this continue statement, which is what Harsh asked about. Right? Now, continue is kind of like break. It is a one-line command that only works inside of a loop, and it affects the loop in an unusual way, in an unnatural way, I should say, right? So basically, break is unnatural. Break will force your loop to end before it would normally end. Right? In our case, the loop would never normally end, so we have to break out of it to get out of it at any point. Now, typically, when you get to the bottom of a while loop, it goes back to the top and asks the question again. While the second part is still true, then run it again. Otherwise, don't run it, right? So it goes every loop, every while loop, or even for loop, any kind of loop, starts here at the first line, goes down to the very last indented line, right here, right, and runs this if need be, of course, and then goes back to the top and asks this question again. Is this still true? If so, then run it again. Right? Now, continue is a command that will say, skip all the code below this and go right back to the top and ask the question again. Right? So the reason why we have this else here, this continue here, because it says here, if you typed in a command that was not one of our recognized commands, then it says here, please feed them or play with them, right? Because please use a command we recognize, right? Please use a command we recognize. Then it says continue. It says it right here so that we don't run this code down here, right? If we took the continue away like this, right, it would say here, please, put in a command we recognize, and then it would reduce the pet's happiness if they were hungry. It would reduce their happiness if they pooped on the floor, and it would kill you, game over, if your pet's happiness was at 0. Right? So I don't want them to get punished for typing in a bad command, to have all these bad things happen if they fuck something up. So instead I say continue here. So if you type in a bad command, skip all this stuff and go right back to the top. That's why that's there. Exactly, Harvey. It's the opposite of a break. Right? A break will get you out of a loop, and a continue will get you back to the top of the loop and run it again. Right? So there are going to be times where you say, I want to redo this loop without finishing it. I don't want to finish this this cycle we're on. Just go back to the top and start a new cycle. So in this case, it prevents the player from suffering penalties for typing in the wrong command. Right? If they type in the wrong command, don't do all this stuff to them. Just go back to the top again and ask them for a new command. Right? Because the first line here is where it asks for the command, basically. That's why we have to continue there. Okay, so let's start talking about what we're going to learn new today. Right? So let's go up here to our notes for the day and start taking some notes. Let's say it's Intro to Python, Season 4, Episode 4. And we're continuing to work on our virtual pet example. Right now, the program is functional, and it has a lot of values that are changing, and based on what the values end up being, different things happen. I'd say, in other words, we have a fully working game, right? That's how a game works. Already, our player can make decisions that have consequences within the game, which can result in them being rewarded. The pet is happy and excited to play, or being punished, right? The pet bites them, and it's game over. In the last episode, we didn't really add any new features. Instead, we talked a lot about code elegance and how to use functions to make our code a bit more readable and manageable. Right. Today, we're going to be doing that again. We're going to be learning some cool features of Python and programming in general that are going to allow us to make our code even simpler and more readable and easier to add to without necessarily changing the program's features, right? On the other hand, unlike last time, we're also going to be applying some of the things we're learning to add new features to our game as well. Right. So what are we talking about today? So far, we have a few different types of data in our tool set as beginner programmers. Right? We have strings, textual data. We have integers, numerical, I'll say mathematical data. We have booleans, true or false data. We have functions, data that, when used, runs code. Also, we now have tuples, data that contains other data. Right? We haven't used that very much. We use that, as you can see, up here. I'm going to demonstrate that real quick. In our return values for our new functions, right? These new functions up here, and they return these comma-separated bits of data. Instead of returning one piece of data, they return 3 sometimes, right? False, pet's happy level, and pet's hunger level. These comma-separated pieces of data are referred to as tuples. So it's treated as one piece of data inside of Python. You can pass it around like one piece. You can see that down here, right? When we feed our pet, we get this value back, returned values. It is itself just one value. It's just this tuple. But you can break up that tuple using this indexes here to get data out of that tuple. The tuple itself is sort of like a package. It's like a little box. And the box itself is a thing, of course. It's a box. But inside of it, you have more stuff. So that's kind of cool. All right, so we have all these kinds of data, right? Strings, integers, booleans, tuples, functions. Right, they're actually called callables. Right. All of these pieces of data are used in different ways. Yeah, objects, right? A lot of these are objects. These are all objects. All these are used in different ways, right? And they empower us as, as creative people to make different kinds of programs. But they all have one thing in common. They're all immutable. This is a new word for us, right? We talked about this very, very briefly at the end of the last episode. Mutability. What is immutable? What is mutable? Right? We talked about this very briefly. We're going to go into that in greater detail today. So basically, mutability refers to a piece of data's ability to mutate or change. Right? All of these kinds of data are immutable, which means that once they're created, they cannot be changed. And that has some pros and cons associated with it. But before we go too far about that, right? Before we go too far into that, questions immediately arise. How can some of these be immutable or unable to change when in our code these pieces of data are changing all the time? Right. For example, we have this sort of code right here. I will say pet's happiness equals 50. Right? Then we're going to say here, if fed food is equivalent to pet's favorite food, then pet's happiness plus equals 20. Right? So in those 3 simple lines, we define a new piece of named data. Pet's happiness. And then we change that data, right? How is that immutable? Well, this is kind of counterintuitive. And as total beginners, I loathe, that we have to explain it so soon. But bear with me, right? This is important to understand as you get stronger as programmers, right? So it's kind of a bit to get into your head mentally. Once you get it, it's going to come in handy later on. Let's just get it over with, right? When you assign, when you use the assignment operator, when you use the assignment operator, which is equals, you are creating a whole new name that may just so happen to be the same as one you used before. In the example above, we are not taking pet's happiness and increasing it. As people with human brains, that's how we interpret it. But on the machine level, what's happening is that we're defining a name called pet's happiness, and then we are replacing that name with a brand new pet's happiness. Right. So let's, we talked before about how the plus equals operator that we used above is syntactic sugar, which means that it's just there to make things look pretty. Let's take that out and see what's really happening here. So we're going to say here, pet's happiness equals 50. If fed food is equivalent to pet's favorite food, pet's happiness equals pet's happiness plus 20. That's what we're really doing, right? That's what plus equals means. It means take the previous value and add its amount to it, and then reassign to the same name. Right? So although it appears here that we are incrementing this value, we are changing this value, we are not changing any value. This 50 here is an integer. It is immutable. It can never be changed. It is going to always be 50. Right? This is going to always be 50, no matter what. And then we add 20 to it, we are making a brand new integer. Right? So here's 50 right here, pet's happiness. That's what it was. Right? That's what pet's happiness was right there. So it was 50. Right? So it's 50 right here. We're adding 20. This is returning a new value, 70. This 70 is the brand new pet's happiness. Right? It is not the original 50, at all. It's a whole different thing. Yes, we used that 50 to make this 70. Right? But it has not changed. It has not grown into being a 70. Right? It was simply used to make the 70, and then both the 50 and the 20 were discarded. Right? They're both gone now. Right? Because the only reference to the 50 was by this name, pet's happiness. And now this name points to something totally different. Points to a 70 now. So that 50 is gone. There's no way to get it back. Right? Because it had this name, and now that name is taken away from it, put to something else. And now that 50 is nowhere to be found. So it's a whole different thing. The 70 that we made is a brand new, equally immutable object. Okay? So, again, it's kind of counterintuitive, because it seems to us that we have increased this 50 into being a 70. But no, we simply use that 50 and the 20 to make a 70. So here's what I'm going to say here, right? With that explanation, I think that you guys are quick enough to understand, what's happening. Right? If there's any confusion, let me know. But I think that kind of makes clear what's really happening, what I mean when I say that this 50 has not changed. It is immutable. Right? But, that also raises another very good question. If this is how data works in Python, where previous bits of data are internally replaced with brand new pieces of data, then are there mutable pieces of data? What would cause a piece of data to be changed then, rather than replaced? And what's the difference? I don't understand. Right? We have this 50, and it doesn't become a 70. It's used to make a 70. So then what kind of data would change? What would be changed? Well, we're going to learn, today we're going to learn about some mutable data types and why they're so damn important and powerful. And we might even talk about some of the shortcomings of mutable data types and why some programmers prefer to use immutable data types whenever possible. Right? So the first new kind of data we're going to learn about is a list. Right? This is such a powerful data type, and it's going to take your programs as a beginner to a whole nother level. There's no comparison. There's no comparison anymore. You're gonna very suddenly be able to make some killer programs. A list is a lot like a tuple. Like a tuple, it's a single piece of data, a box, that contains other pieces of data. Right, that's pretty much what it is. In fact, you'd be forgiven for thinking at first that they work exactly the same way. Like exactly. Here's an example. Okay. We're going to say here, we're going to make a tuple, right? I'm going to say here, this is a tuple. You guys know this is a comment, right? If you start a line of Python with a hashtag or with a pound sign or a number sign, that means that line is a comment in Python and is ignored by Python. Right? So this is good. In our hypothetical, Python, we're not actually running Python here. If we were, though, this would be a comment. Right, so this is a tuple. We're going to say here, Harsimus. Harsimus is a tuple, right? He's got a name, Harsimus. Right? He's got an age. I think he's 64 years old. He's got a height. This guy is 8 feet tall, right? And 3 inches. And he's a profession, right? He's an assassin. 65. Okay, 65 years old. There you go. So all the things are true about Harsimus, right? So we have this tuple, right? This tuple is defined like we expect, right? It has these comma-separated, data values. It's enclosed by parentheses, right? This is now a tuple. So we can access things. Like we can say, like, we can say things like, I'm sorry. We can say Harsimus's name is Harsimus. I'm gonna call this Harsimus data. Right? Is Harsimus data in the very first index, index 0, right? We can see that right here, right? So Harsimus, his name is in the first spot in the tuple. That means index 0 in that tuple. Right? Or we could also say here, Harsimus age is Harsimus data 1. That's the second index because that starts at 0, right? That's right there. Harsimus height feet is Harsimus data 2. That's the third slot right here. Harsimus height inches is equivalent to Harsimus data, in the fourth slot, index 3. And finally, we have, Harsimus profession is Harsimus data 4, right? That's the fifth index, right? 1, 2, 3, 4, 5 is the profession, right? So basically, we have this tuple. It contains a bunch of data in it, and we can get the data out one at a time if we want to, right? Normally, we wouldn't do this. If we were going to do this anyway, we wouldn't have made a tuple, right? Why would we define all these variables? Why would we even make the tuple in that case, right? So usually a tuple is there to kind of condense data into one group that makes sense. This is all about Harsimus, right? It's all about Harsimus, so it kind of makes sense. And I'm just showing here that you can access the data one at a time using these index numbers, right? 0, 1, 2, 3, 4, right? To access all the little bits of data in there. I'm going to say this is a list, right? So I'm going to say here, this is a list. I'm going to say here, friends, right? We've got Harsimus. We've got K. Reich Jr. Right, we've got Dick Zucker. Mr. Part 2. Right? Black Jalapeno. All these guys. Right? So, right away, we see something different about this. Right? Maybe you don't, because it's kind of not that obvious. For one thing, tuples are created by putting a comma-separated, list of things into these parentheses. Right? Whereas a list is a comma-separated list of things, but they're inside these square brackets. That's apparently the only difference right now. In fact, I can even say down here, first friend equals friends 0. Second friend equals friends 1. Third friend equals friends 2, and so on. Right? So in fact, you actually get the data out the same exact way as with tuples, using these index numbers. Right? So friends 0 is right here, first slot. Friends 1, index 1, is the second spot. And index 2 is the third spot, just like tuples. They're exactly the same. Right? So, let's begs the question. How are they different? Well, for one thing, conceptually, theoretically, abstractly, they meet different needs. A tuple is a bunch of related data that together serves some purpose. In our example, we created a tuple that explains a bunch of different things about Harsmus. Right. On the other hand, a list is a sequence of data. Right. Now it's a subtle difference, but our list of friends is a bunch of the same thing, you know, names, in a list. Right. Whereas our tuple was a bunch of different things that all relate, that all work together to do one job, right? Describe Harsmus. Right. So you know that's the conceptual difference between tuples and lists. You know, they meet different needs. But in terms of Python, what's really different about them is that lists are immutable. They can be changed. So let's say that I have this list of friends, and I make a new friend. Right. What I can do, you know, one thing that I can do with a list that I can't do with a tuple is add a new piece of data to this list. Right. So I can say here, you know, friends dot append a new friend to the list. Right? Append means add. Add a new friend to the list. We're going to add, you know, Overlord Steve. There you go. So now our list of friends has a new piece of data added to it. You know, if you know, Harsmus really hurts my feelings, I can remove him from my list of friends. Like this. We can say friends.remove Harsmus. I would never do that, but we could do that. Right. In comparison, if we wanted to do something similar with tuples, you know, such as to add a new piece of data to describe Harsmus, we would need to make a brand new tuple like this. So we say here, new Harsmus data equals a new tuple. We're going to say here, I want Harsmus data 0, Harsmus data 1, Harsmus data 2, Harsmus data 3, and Harsmus data 4, and then finally our new value, right? Which is going to be, you know, Hars's main, which is Makoto. Right. Well, it's not really, it's the girl he most wants to kiss in Third Strike, Makoto. Right. So basically, we used the data from the first tuple, and we made a brand new tuple. Okay. So, you know, in an abstract sense, I think we all understand that, right? Sometimes, in programming, you have to create entirely new data that resembles your old data. Other times, you can just change your existing data. You know, the first is immutable, and the second is mutable. So, you know, what's the difference then? Like, yeah, we understand that much, but why? How do we use this? You know, how do we make use of this knowledge? It seems to be totally arbitrary, right? It seems to be like, you know, some can change, some can't. Who cares? Right? It doesn't seem to make any difference in the end. We still made a new tuple, right? We changed our list, made a new tuple, same difference, right? Well, here's where it matters, right? Let's go look at our code. We're getting back to the code finally, guys. It matters because when you have access to an object, right, this piece of data, right, you're holding it in your hand, hypothetically speaking, in this program, right? Your program is holding it, right? If it can change that data then it's kind of abstract. Then that data can change, right? Let's go look at our functions here, right? Our functions. So here we have this play with pet function, right? And it has in its hand this pet's happiness integer, right? When we run play with pet, we give it an argument, right? It's a function, it has an argument. We feed it the pet's happiness value, right? So now it has that very integer. We made it 50, right? We said, pet's happiness is 50. We gave it that to play with pet, and now play with pet has that 50 in its hot little hand, right? It can read it, it can use it, and it can make a new value called pet's happiness, but it cannot change that 50. And for that very reason, we have this necessity to return a new value, including pet's happiness, right? Because the outside world that called this function, let's go down here to play, right? The outside world has access to this value, pet's happiness, right? It has access to this value called pet's happiness. And in fact, it fed it into this play function, right? It fed it in there itself. So it said, I have this 50, it's called pet's happiness. I'm going to give that to you, to use function. So function now has that 50 in its hand, right? But the thing is, because that 50 cannot be changed, even though the outside world has access to that 50, it cannot have access to any new data that is made inside of this function. I know it's kind of abstract. So although the outside world has access to that 50, pet's happiness, the function cannot change that 50 and have that change be reflected on the outside world. Because again, the outside world only has the 50 that it started with. Right? So yeah, so here in play with pet, it can change that value. To where, it can use that value however it wants. It can use it, it can do math on it, it can do whatever it wants. But it's by the time, if you were to change the value of pet's happiness, right? Change whatever numbers associated with that name. We're talking about a brand new object. We're talking about a brand new integer. And so what the outside world still has is that 50 that was originally there, right? And inside the function, you made a whole different kind of integer. And if you want to get that integer out of the function, you have to return it. Right? You have to say, here's this number that I made. Now you can have it. Right? What's different about that is that if this were a mutable object, like a list, right? If we fed in, pet's toys, right? Maybe, just as an example, let's go down here to our code, right? I'm going to say here, before we call play, we can say here, pet's toys is a list. It's a list of things like, ball, biscuit, whatever, right? Whatever it's got there, it's some dog stuff, right? Dog stuff. It can feed this list in to this function right here. So now the function has access to this list. There you go. Right, so now the function can read this list, right? But because this is a mutable object, it can also change this list. Like it could not change the pet's happiness. That was an integer. That's immutable. But it can change this list. For instance, let's say here that when you throw the ball or whatever, right? Whatever, hypothetically speaking, we can say here that pet's toys remove ball. Right? So when you played the pet, you lost the ball. Maybe you threw it too far. Maybe it went on the roof. Who knows? You've lost this ball now. So by doing this, we have not made a new list. We have just simply changed the list we were given. And for that reason, we don't got to return the new list because the outside world still has access to that same list. Right? The outside world has access to that pet's toys list. Right? So we changed it here, but it's still the same list outside of that function. So even outside of that list, outside of that function, that list has now changed. Right? So if I were to run this code here, and then go down here and say, to our play code, we ran the function right here, right? If we were to say here, print pet's toys, the value would be just the biscuit, right? Because by running this function, we have changed this list. Right? So down here, pet's toys is going to not have the ball anymore. It's going to have just the biscuit. Right? We can't do that same thing with a number because the number is immutable. So I feed in pet's happiness as a 50, right? And then inside of the function, it can use that 50 and make a brand new 70. But what we have out here is still that original 50. We don't have that 70 the function made unless it gives it to us. Right? On the other hand, by feeding it this list to play with, it can actually change that list. That list is immutable. That list can be changed. And then outside of that function, that change is still reflected because it is the same list. Right. So that's mutability and immutability. That doesn't really completely explain how we're going to use it today. Right, so let's go here and take some quick notes in our little notes document. Right. On stream, we just discussed how mutability plays a factor in how we use the arguments that a function is given. Right. If a function is given an immutable argument, however it chooses to use that argument in its code, the outside world that fed it the argument will always have the original value stored. Right. So if a new value is assigned to the same name within the function, that doesn't matter. Outside of the function, that name still refers to the original, immutable value. Right. What happens in your function stays in your function. When you define or redefine a name in your function, that doesn't change any of the names outside of the function. If you feed a function a pet's happiness value that's 50, the name pet's happiness outside of the function will still be 50 when the function ends, regardless of, whatever names are being defined or redefined inside of the function. Right. So yeah, we can make a brand new integer inside of our function and call it pet's happiness. But that doesn't have an impact on the names that exist outside of the function. So pet's happiness outside of the function still refers to 50, even if inside of the function we said pet's happiness equals pet's happiness plus 20. Right. In that example, within the function, we are making a new object, a new integer, 70, and we are giving it the name pet's happiness, which only works inside of the function. Right. That's true inside of the function. So talking about Shun here. You know me, dude. I never start talking about Shun. Okay, so on the other hand, right? On the contrary, if we feed a function a mutable, changeable piece of data, that value can be changed within the function, and those changes will be reflected outside of the function. Right? Because unlike with an integer, or string, or tuple, or whatever, we're not talking about creating a new name with a new value. We're talking about taking this object that we were given and altering it. Right. So outside of the function, that list, has changed. We're not talking about creating a new variable inside of the function that only exists inside of the function. We're taking the very object we were given and altering it. Good night, Harsmus. It's happy coding. I will think about this lobby stuff. Good stuff, Hars. I look forward to hearing from you on Discord. Hope you have a lovely evening. Here, so I did share my take on what you and Dave were talking about on Twitter. Dave is fucking great, man. Dave is great. He's the coolest guy you're ever going to meet. Poverty game night. I don't expect everybody to agree with my feelings about Chun. And I'm also not convinced entirely that my feelings about Chun are, you know, like, the be-all, end-all, most informed opinion. I'm not that strong of a player. Right? But that's just how I feel right now in my game where it's at. And until I find, you know, compelling evidence of the contrary that works for me, I'm going to have those feelings. I have no doubt that, you know, 10 years from now, I'm going to look back on this and say, I'm sure that, you know, a lot of these guys that disagree with me were right in many ways I didn't really understand at the time. Is that blaming the tool is weak and holds you back? Yeah. Here's what I think about that, right? I think that if you go into a gunfight with a knife and you want to win, you definitely have to understand the difference in potential between, you know, the two opponents, right? Your opponent and yourself. You have to understand that you're at a disadvantage, and you have to overcome it. You have to overcome it, right? So if you look at this guy as a gun, and you say, that's why I lost, then you're not looking at a way to win. You're not saying, how could I have won with this knife? Right? You're never going to beat the guy with a gun with your knife if you don't look at how you can use your knife to win. This isn't a clear A and B scenario, though. You just don't just have one tool. In the game we're talking about, we have 19 tools. Okay. I think my point still works out the same. Right? If you both have 19 tools, and your opponent has 19 tools that have an advantage over your tools, it's up to you to find the tool you're most comfortable with. Oh, I see what you mean. You're talking about. I see what you mean. Here goes. You're making the argument that I've heard other people make too, which is that I'm not sure if that's really what we're trying to make the argument, but it sounds like what we're trying to say is that I could have, if there's two guns on a table and two knives, and my opponent grabs a gun and I grab a knife, then at that point I can't say I lost because you picked this gun, right? Okay, so how are we going to use these, right? So we kind of understand how mutability has an advantage, right? Over immutable objects. Right? We kind of understand that now. We understand that it seems to make more sense to us as human beings if we can feed a piece of data into a function and then have that function change that data and then have that data be reflected, you know, that those changes be reflected in the outside world. That makes sense, right? It's pretty clear. That's what you'd expect. Maybe it makes more sense than an immutable piece of data. We have to kind of return these values back out again. But how are we going to really use these to our advantage? Right? Well, the first thing we can do to use to our advantage is to take all these arguments and make them mutable, and then we can sort of replace these return values with just changing the data of the objects. Right? So I'm going to make this note here in my notes here. You know, immutability at a higher level of programming arguably has advantages over mutability, because once you start changing values, you know, behind the scenes within functions, you can run into bugs very quickly where you forget what values you changed and where. Right? By explicitly feeding arguments to functions, not changing anything within those functions, and then explicitly getting new data out of those functions with return. You can make it very clear how your program is working. Once you start changing data within your functions, it can become much more difficult to know where and why things are happening. It's not even too good to know. It's like several guns, a couple knives, some sledgehammers, and a yellow balloon animal people call Sean. Poor Sean. Okay, so I'm going to say here, we're going to put lists on the back burner for a few minutes and talk about our second and final mutable data type for today, dictionaries. I wanted to bring up lists first because they're a lot like lists, right? And lists are a lot like tuples. In a list and a tuple, you package a bunch of data together and access that data by an index number, right? Which represents the order in which the data appears, right? Index 0 is the first slot of data. Index 1 is the second slot of data, and so on. A dictionary is also a package of other pieces of data, right? It's exactly the same, it would seem. However, the data inside of a dictionary is not accessed by index number in order. Instead, the data is accessed by a key, which is another piece of data, right? So watch this. We have this piece of data, right? We're going to say here, we'll say, what's a good idea? I always use the food colors example, right? The food colors example is the food colors example is a good idea, a good example of a dictionary. So we're going to say here, we'll say a food by color. Food by color. We have this dictionary. Dictionaries have these curly brackets that define them, right? So lists have these square brackets. Tuples have these round parentheses, and dictionaries have these curly brackets around them. We're going to say here, red, apple, yellow, banana. What's another good fruit? Another top tier fruit. We can say, purple. It's a grape. I think it's more of a berry than a fruit. Whatever. That's the idea, right? So we have these pairs. See these commas here? I can't say orange here, goes. I always use orange. The thing about orange is that orange is just orange. I'll put that in there too, though, anyway. Berries are fruits? Okay. Works for me. Orange. I'm not a botanist. Orange. Okay. So we have these pairs that are separated by commas, right? We have the key, then a colon, then the value, then the comma. Right? Colors of pineapple. I'm too colorblind to know what a pineapple is. Is that also yellow? That's the things that kind of complicated. I think I'm not going to fuck around with that too much yet. So we have red, apple, yellow, banana, purple, grape, orange, orange. And they're all separated by commas. Right? So now, I can say this. I can say, to get apple out of the dictionary, I can use this. Red fruit equals food by color, red. Okay? So as you can see, we got apple out of the dictionary in much the same way. You don't like pears, here goes? You son of a fucking bitch. I like pears more than oranges. I like oranges, though. We got apple out of the dictionary in much the same way that we would have if it had been a list. But instead of using an index number representing the order of the elements, we accessed, you know, the value by its key. Right. So food by color red, that points to apple. Right, so we get apple out of here. Okay. And just like a list, dictionaries are mutable. So we can add new keys and values to the dictionary quite easily, as well as you know, swapping out values. So if I want to say this, I want to add you know, green to this. I can say here, food by color, green equals pear. What's up, Zanzu? Welcome aboard, bro. How you doing, Sekiro? Did you get any rest last night? That Rick Ross pear meme is top tier, though. I don't think I've seen that meme. You're playing it right now. Let's go, Zanzu. Are you enjoying it? Food by color green equals pear. So we've added a new value here. Feels bad, man. Oh, but you suck. I see. It's gonna take some practice, I'm sure. It's like any Dark Souls game or any FromSoft game or any game that requires any kind of skill. I got you, Zanzu. How much older is your older brother? Oh, you're playing right now. I see. But you're not playing Sekiro. Path of Exile. I gotcha. It's easier than Dark Souls? Well, it's not necessarily a bad thing. There's a lot more to a game than how easy or hard it is. Thank you for the follow, 30,009 Sesu. I'm sorry, it's pretty quiet. I have to fix that volume here. The little ding-a-ding wasn't that loud. Okay, so we can add new values. We can add new keys and values to our dictionary, right? Just like this. So we define its index, and then we assign it a value, right? Kind of cool, kind of basic. Likewise, we can, you know, reassign values. Food by color, you know, red. Well, that can equal, you know, raspberry instead of apple. We can also remove values entirely using the del keyword. You know, del. I think that's how it works. Food by color green, because fuck a pear, right? That's gone now. Pretty sure that's how you delete things. I don't think you use a remove. I'll use remove like you do with a list. Parry timing, dodging, I'm bad at both. I can block, but when it breaks too fast, also it's got pretty good block breaking, huh? Not that I mind it, says Zanzu. I've been experimenting with really lame ways of play, and I'm glad to tell you, it is 110% viable, huh? And that's probably what I'm going to end up doing. You know me, I'm really fixated on not dying. So what I usually do is gravitate toward whatever has the least chance of dying. If I can find a way that'll help me survive, then I'm going to probably do that until it doesn't work anymore. And then complain about it. Because it stopped working. You can die twice? Oh, really? Okay, well, that's probably why it's called that, huh? Okay, so we have these dictionaries. I haven't really done a lot of coding. It's more of concept stuff today. I'm sorry, guys. Usually I try to code and have some more, you know, examples in front of you right away. Here's been a lot of lecturing. But we know about two new kinds of data now, right? We know about lists, and we know about dictionaries, right? So before we get back into our code, right? And see how all of these new data types are going to help us. Let's review the data types that we have to work with now. Right? We have strings. We've got integers. We've got booleans. We've got callables, which are functions. We've got tuples, which, you know, contain data. Data's all related to one thing. I'm going to make some notes here. Text, math, you know, logic, true or false. Right? Callables are like functions. And we have these tuples, which are, you know, a box of data, you know, for a single purpose. Now we also have lists and dictionaries. I'll call them dicts, right? I know it sounds kind of weird when I say it, but they're called dicts in the actual Python. Dictionaries. So lists are a sequence of, you know, similar data, right? And then we have dictionaries, which are data organized by key, right? Organized and fetchable by key, rather than order. Is it okay, right? Then says dicts, where? Oh, dicts. Yeah, we're talking about dictionaries. I think my speech impediment makes it kind of hard to say. Dicts. Not sure if you guys can say that or not. Maybe it's just me. We got K-Reich. The Gaud. Okay, so we have these two kinds of data, right? The two new data types, dictionaries and lists. The first thing I'm going to do is use a dictionary to simplify our functions by packaging the entire state of the game into one piece of data, a dict, that we can change and you know, mutate on the fly. That way, our functions can all look uniform when we call and use them. You know, they don't have a million unique arguments and return values. All right, so let's get back to our code here and actually make some changes. You have a list of 2? I've never noticed that before. I know I do. Oh, so does here goes. I've trained it really hard so it doesn't come out often. I try too. But especially if I get excited and talk fast, it comes out really strong. I cover it pretty well, but I still hear it, huh? I wonder if everyone feels that way. What if everybody has a speech impediment? They're trying to hide it as best as they can. Okay, I'm sorry, guys. So we have this function, right? We have two functions, really. We have feed pet, and we have play with pet. Welcome aboard our bread sieve. I thought this was on fast forward. I'm sorry, dude. I talk very fast. I apologize. It's a habit I have. So black stutters, huh? I do that sometimes as well. So talking is hard, guys. I guess what we're getting at here is talking is hard. I've also trained my voice to not have an accent. That's why I have that weird, from nowhere in particular, speech pattern. You know, I wouldn't say I noticed that, you know, explicitly here goes, but when you mention it like that, I kind of can hear it. Yeah, kind of like I said, an NPR voice. Never really noticed. I wouldn't have noticed it if you hadn't mentioned it, but now that you mention it, maybe. I've heard people say that I sound kind of Canadian as a Michigander. I kind of have an accent in that respect. Anyway, so we have these functions, right, we defined. They take a bunch of arguments, pet's name, pet's happy level, pet's hunger level. They return a bunch of crap, right? False, pet's happy level, pet's hunger level. This one here takes different stuff altogether, right? It takes pet's toys for one thing. And it returns a bunch of other crap too, right? It doesn't return other things. So basically, these functions take in a bunch of different arguments and return different stuff. So when we call them down here, you can see that we have these very long lines where we're kind of feeding a bunch of random values. And we're getting out a bunch of stuff too. And we don't really know what it is right away. Thankfully, our program tells us what it is, right? The fed pet rocks value, the pet's happiness level, the pet's hunger, whatever. And down here, it's different, right? We play, it's a whole different situation. It only returns 2 values, takes different stuff. It's kind of confusing. So because the feed function and the play function are both used more or less the same way, right? We take this argument that the user typed in, they type in either feed or play, and then we call that function, right? So there's sort of this uniformity there. We can kind of see that in the abstract sense. There's a uniformity there. It's frustrating then that when we actually call the functions, there is so much different stuff going on here, right? So I propose that we really examine what these functions are doing, right? What they're really doing is they are taking the state of the game, including the pet's name and their happy level and their hunger level. Right? That's pretty much all of the currently saved values in our game, right? We also have, like, you know, a poop on the floor. We have a couple other trivial bits of data in our code, but more or less, to feed our pet or to play with our pet, we kind of have to know what's going on in the game, Right? You guys would all agree with that, I'm sure. So for that reason, I'm going to condense these values here into one piece of data. Right? Instead of having a bunch of pieces of data to feed to our functions and get back out again, we're going to make it one piece of data, which is in the abstract sense representative of our game's state. That is a piece of data now, right? You could see how that's a piece of data, but inside that piece of data there's other kinds of data, right? Do an audiobook, reading and sell it, huh? It'd be like the fastest one you ever heard. I could read all of Moby Dick in 10 minutes. You don't sound like a Canuck, but you do sound like a carpetbagger. I'm not sure what the hell a carpetbagger is. Sounds racist. Kenny says, I'm strongly thinking about getting Sekiro and streaming it. I think that'd be a lot of fun, Kenny. I don't think I could watch it for sure. I really want to play it myself blind. Sanzu enjoys it. Heroes enjoys it. I spoiled things a bit by watching a friend play it. Did you ever play Horizon, King? How'd that come along? You've done a lot on the last Friday. Zanzu played it blind, huh? Sekiro! So I haven't watched anything about it either. I don't think I want to. So now we have these values, right? We have a bunch of variables we defined in our program. Let's re-examine how this works and make it a dictionary. I'm going to call this game state. It is now an empty dictionary. Okay, this object here can be changed. It can be fed to a function. That function now can change the game state without having to return a bunch of data. Right? I want to also stress to you guys one more time that as you become stronger programmers, you're going to find that doing things this way is not always the best way. Like I mentioned earlier, guys, if you start to change data inside of functions instead of returning data, then you're going to have bugs later on once your program reaches a certain level of complexity. So there's a balance to strike as you become a stronger programmer to decide when to use arguments and return data, or return values, and immutable objects, versus when to use mutability as an advantage to sort of simplify things. Basically, mutability simplifies things, and immutability makes things more reliable. So we're simplifying things right now, maybe at a cost one day. So let's say your game state, pet's favorite food, 1, right, equals French fries. So what have we done here, guys? We took this raw variable, right? This variable we had here, pet's favorite food, is equivalent to a string, where we assign this string this name. But now instead of doing that, we are instead making a key in this dictionary, pet's favorite food. We are assigning it this value, this string. So now instead of getting the pet's favorite food by typing that, we get it like so. Game state, pet's favorite food. We're going to be accessing it using a key from a dictionary. Right? So we have this game state now. Oh, you're near the end. Wow, Kenny, I didn't realize that. In Horizon Zero Dawn. So we have this game state dictionary, and we're getting it using a key to get data out of it. Right? Okay, so let's do the same thing for our other variables. I'm just going to copy paste this, to be honest. I'm going to grab all this stuff, copy it, and paste it here. Okay, so now we're going to say here, game state at the key, which is a string in this case, right? Pet's favorite food 2, assign that the data pi. Likewise here, game state dictionary at the key, pet's hated food, make the value orange. We have this game state dictionary at the key, pet's happiness, make that an integer, 50. Likewise, a game state pet's hunger, make that an integer, 100. And finally, our last value in our dictionary here, game state poop on floor, is a Boolean value equal to false. Okay, so now instead of having all these loose variables in our program, right, that we can call normally, like see this variable call we have here. Thanks for the sub, Circus Cancel. Amazon Prime. How you doing, dude? So I had a crazy morning. I got up at around 4 o'clock for the stream. Catching up on Twitter. Twitter's blowing up right now. Circus Cancel of Scrub Series, twitch.tv/Scrub Series. Go check them out every Sunday, guys. They have an awesome fucking stream over there. Every Sunday they get together locally with 2 arcade pieces of hardware, It's fucking sick. They have 2 CPS-3s. So jealous. So awesome. And they have a bunch of guys show up and play Third Strike. That's the dream. That's the dream all over the country. And they got it there in La Crosse, Wisconsin. Circus, you are definitely not at all to blame, my dude. The only thing to blame are my extreme feelings about Chun-Li and the emotions that come from being a human being in a game that's very competitive. That's all there is to it. Right? There were hurt feelings yesterday. I don't feel great about it. But when you're playing a game where there's a winner and a loser, there's going to be sometimes a lot of emotion wrapped up in it, for better or worse. Okay, so we've got this new dictionary, right, that has all these values in it. So what's really crazy about this now is that we can take these... Let's go down here to our... when we play with our pet, or when we feed our pet, let's say, right? Let's go feed our pet now and see how this all is changing now. Now we're using mutability to our advantage. Here in the feed code, the way it works right now is we get a return value from the process of calling this function, feed pet, and we give it all of these pieces of data individually as arguments. Okay? So I said before that when you give a function arguments, you give it the data that you need for that function to run, to do its job, right? We established that very early on. The arguments are the data the function needs to do its job. But now I'm going to abstract that and say the data that feedPet needs is it needs to know what's going on in our game, right? And now we have one piece of data, this game state, that can tell you whatever you have to know about what's going on in the game, right? Because this piece of data, the game state, contains a bunch of other pieces of data that refer individually to what's happening in the game, right? So now I'm going to say here, instead of feedPet all these random arguments, I'm going to say feedPet the game state. Now it has one argument, which is the state of the game. Okay, and furthermore, it does not need to have return values anymore. Right? Because we fed it a dictionary, and the function itself can now change these values in the dictionary. The dictionary is a mutable object. Right? The dictionary can be changed inside of the function. So now the function has access not to a immutable piece of data that it can use to make new data. No. It's changing this dictionary. Right? So when the function's over, our dictionary, our game state, will be changed because our function here is actually changing that very dictionary that we fed it, not just using that to make a new dictionary. Hell no, it's using it to actually change it. So now we don't need a return value anymore because we've broken the rule. I'm going to comment over here about this, right? I've talked about how mutability can make a program simpler, but perhaps at the cost of making it harder to keep clean, right? Immutability can make your program visually much more complex and difficult to manage in that respect. But it makes it a lot easier to solve bugs in the long run. No single approach, avoiding immutability or avoiding immutability is going to make a great program. You have to leverage the advantages of both in order to, create a beautiful program. In our case, as beginners, we're learning about mutability as a way to simplify and make more uniform the way that our functions behave. We're explicitly feeding them only one argument now, and we're allowing the functions to make changes to the game state without having to explicitly return new values that we have to deal with. Right? So on the one hand, our program is going to start looking a lot simpler. And that's awesome. That's really awesome. Right. On the other hand, I want to clarify that we are now breaking the rule that I've been stressing since the beginning of our last stream. What happens in the function stays in the function. That's no longer true, guys, because now the function can change things outside of the function. And on the one hand, that's super powerful. That's super convenient. On the other hand, you can see already how having a function be able to change things outside of it could make your code more confusing. Right? Now our code is not quite as explicitly broken up into pieces. Right? Now things are becoming more interwoven in a way that could become a tangled mess at some point. That's what's referred to as state in programming circles, right? It's the problem of state. Some programmers completely avoid state because of how it can get very tangled and messy. And they prefer things to be very separate and neat and tidy. But if you start to interweave things, they can communicate better and also make your program a lot simpler to write and to read. Right? So it kind of makes sense for certain things to be interwoven, right? Again, the feed function, it needs to know what's going on in the game, and it needs to change things that are happening in the game. So give it the state of the game and let it change it, right? That makes a lot of sense. Again, one day we might find that it bites us in the ass, and we have to sort of decide how much state, how much interaction we really want between our functions and our data, right? There might be a time where it makes more sense to have it be all separated, but for now, look at the advantage we've seen here. We made these, like, 6 lines into 1 line. We made this long-ass function call with a return value into a very simple function call, and it's more or less clear what's happening here, right? We are feeding the pet, and for that to happen, it has to know the state of the game, right? That's not too much, that's not too bad. Thank you, Espartaco, for the follow. We do Intro to Python programming here every Friday. We talk about tutorials, we talk about how you could look at Python as a total beginner. So Black says, I'll be home late, Venka, but I'll look into Facebook when I get back. Good stuff, Black. Yeah, that'll be probably happening around like 4 a.m. Eastern time. But I'm looking forward to that. Always a pleasure to have a friend on Facebook. I'm not really huge into social media. There's a lot of shortcomings with it. There's a lot of pitfalls in social media. At the same time, I found over the past couple of years especially, that it's a really cool way to keep up with friends and stuff. It's got pros and cons. To me, many more pros than cons. Right? Sometimes you see something frustrating on social media that kind of pisses you off or whatever. But at the same time, it's a great way to kind of be able to very quickly see what all your friends are up to, and that's kind of a warm feeling. Okay, so now we have this new function, feedPet. It's just like our old function, but it takes 1 argument instead of like 6, and it returns no data. It just does a thing. feedPet now does a thing. So let's go up here to feedPet and change the way that it works internally to reflect that. Here we go. Here's feedPet, right? It takes pet's name, pet's happy level, and pet's hunger level as arguments. Fuck that. 1 argument. Game state. It takes the state of the game. It knows what's happening in our game now, right? The argument is what the function needs to do its job. It needs to know the state of the game. Now it knows it. State of the game. Game state. Okay, so we have to save, what kind of pet's food you want. It says here, what do you want to feed pet's name? Well, we don't have that argument anymore, right? We don't have this argument pet's name anymore. What do we have? We have the game state instead, right? So we have to call this by the game state and its key. So we haven't assigned that yet. Let's go look at our game state, right? We have a pet's favorite food, and we have their hunger level and stuff. We don't know their name yet. It's because right here, we haven't changed this line yet, right? We make this variable here, pet's name, and we assign it with input. I'm going to change this now to say game state. At the pet's name key, we have this value returned by, the input call. That's fine. Okay, so now let's go utilize that up here in our function. So we have the game state, so that means we have a dictionary that has this key that we want, right? Let's break a few lines here, because it's going to be a little bit long. Let's say here, game state, pet's name. Right. So now we have this string, which is what do you want to feed, and then from the game state at the pet's name key, whatever value is there, plus question mark. So what do you want to feed Jose? What do you want to feed Black Jalapeno? What do you want to feed Vencabot? Right? So we can save this value, this string, to this dictionary at a key. The key is its location. Right? In a list, we use an index. In a tuple, we use an index number. Right? In a dictionary, you use a key, which is another value that's associated with that other value. Right? So we have this string pet's name, and it's associated with, the name of the pet. I also want to stress, guys, that we can use F strings in Python 3. I don't want you guys to see this and think that it's going to always be this ugly to combine strings together. In fact, F strings are awesome. I invite you to look them up on your own time. They're a little bit more magical than I want to get to here with total beginners. So we're going to actually use explicit concatenation. That's a fancy word of saying string addition. Squeeze things together with these plus signs, basically. So what do you want to feed? There's one string. Plus, concatenate that with the game state pet's name. So that's our, our pet's name. Concatenate that with a question mark. So what do you want to feed? Vencabot. Right? With an F string, we do it like this. Watch. F. This. Go over here and do this. And, at some point, you're going to be doing it this way. It's a lot tidier. It looks a lot neater. But it's not totally clear how it works for a beginner. So I'm going to avoid that for now and make it more clear that we're explicitly adding strings together. That's what we're really doing here. We're adding strings together using these concatenations. Or concatenation. I try to pronounce it exactly. Basically, we're just adding them together. Okay, so we have these three strings. We're added together now. That's great. Let's continue changing our old code that requires regular-ass variables and change them to being keys in a dictionary. Okay, so I'm going to say here, if pet's food is equivalent to game state pet's favorite food 1. I'm sorry, I misinterpreted this. It's fine. Go up here. Fix this line. I'm going to sneeze as well, guys. I apologize. Okay. So if we're going to say here, if pet's food is equivalent to game state pet's favorite food 1, or pet's food is equivalent to game state pet's favorite food 2. So we no longer have this pet's favorite food 2 argument, right? We got rid of that. Instead, we have this dictionary that has these keys, right? I want to really kind of drive that home. So we don't have an argument anymore called pet's hated food, right? We haven't defined that up here. All we defined is game state, right? So all we have access to is this game state thing. That's fine though, because the game state itself has access to this data we need. We access that by using the key that we want. So I'm going to say here, use the game state that we got as an argument, and get this data out of it using this key, pet's hated food. We define that right down here, right? Pet's hated food right there. We use a string as the key, and then we attach the string to that. This is the value of that key, right? Orange is currently it's hated food. He hates oranges. Also, this pet's happy level, right? We don't have that anymore. Instead, we're actually going to be changing the value of the game state. It's a mutable object. This object is changeable. It can be mutated. It is mutable. And for that reason now, we don't need to kind of make our own pet's happy level value and then return it back out again, right? We don't have to make a new value anymore and return it out. We can simply make a new value, make a new number, and save it to that game state, because that game state can be changed. Things can be saved to it. So I'm going to say here, game state pet's happiness level, what are we calling it down below, plus equals 20. So again, the integer itself, guys, is a immutable object. It cannot be changed, right? So if it was 50 and we added 20 to it, we are not getting this new number 70 back. We are not getting this as like the number 50 that grew by 20, right? Instead, we are using that, value that was a 50 and using 20 as well to make a new 70. So we have a brand new 70, but here's the thing, guys. Although the integer itself is immutable and cannot be changed, the game state is a dictionary and can be changed. So we are saving this brand new integer to our dictionary. Okay? So the dictionary is changing, right? The 50 isn't changing. The 50 got replaced entirely. We talked about that earlier, right? How it's immutable. So the 50 got replaced. It's gone now. We have a 70 instead. But the dictionary has changed. It has a new value saved to this key. So now outside of the dictionary, we can find that value with this key. Thanks up, Ryan. Heavy pen. You know how we do it here, dude. Gotta get them views. Let's go to our game state. There's this pet's happiness level, right? If you guys, most hated food is going to reduce his happiness by a lot. So now our game state's new value at the pet's happiness level, key, that's the key, right? Its new value is whatever it was, minus 40. Okay, so we have actually saved a new value to our dictionary. The dictionary is mutable. It has now been changed. Okay. There we go. So I want to, if you try to feed them rocks, we just end the function with return. Good. Can you make a setting to where if you eat a pear, the game says, shout out to all the pears? Yes. We'll do that right now. So we'll say here, elif pet's food is equivalent to pear. We can say print shout out. I'm going to use the same exact exact typing that here goes did. Shout out to all the pear. Okay, and I'm gonna make him happier because I like pears. Fuck you, here goes. I say with nothing but affection. So I'm gonna say here, game state, pet's happiness level is going to now go up by a solid 30. That's actually more than his favorite food. No, like I'll go up by 10. And more than his favorite food. Pears are good though. Okay, so now if you feed the pet a pear, it says that. Here goes something, a link to this. I think it's probably a video. Is that this Rick Ross thing? I don't think I've seen that yet. Okay, so now we're going to say here, if it was like some kind of other food we don't know about, we're going to lower its happiness. So we're going to say here, game state, right? We're using the game state again. We're going to save a new value to it. Pet's happiness level. And we're going to change it by 10. We're going to lower it by 10. Whatever it was is being reduced. Okay. So, now we can, I'm going to show something. I'm going to use a list here real quick, too. I'm eating pears and shit. So we have pet's name, right? It's actually going to be pet's name. It's going to be a game state pet's name. Because we don't know pet's name anymore. We have the game state, though, which knows the pet's name. There we go. We're going to say here, if a game state, pet's happiness level, is greater than or equal to 80, then print off, game state, pet's name, seems ecstatic. Right? If they're really happy, then print that off. Otherwise, if the game state pet's happiness level is greater than 50, then print off, game state pet's name, the pet's name from the game state, seems in high spirits. Otherwise, if the pet's happiness level we're getting from the game state, right? We don't know this level anymore. We don't know it, directly. But we do know the game state, which knows it. So we know it indirectly. We can access it like that. Print off again. Same with the pet's name, right? We don't know the pet's name directly, but we do know the game state, and the pet's name is saved in the game state. So we can get that out of there now. And finally, if it's really an unhappy pet, access its name from the game state. There you go. Awesome. Now we can change their hunger level as well. So we can say here, game state, pet's hunger level. Sig says, I have no desire in playing tonight. I understand, Sig, now. Just feeling kind of down in the dumps, homeboy? Or just feeling not really in the mood to play some Minecraft? So we're reducing the hunger level in the game state. And once again, guys, we have no more return going on here because we actually changed all our values right inside of the function, right? All the values that are being changed and saved inside of this very function. So this return value is no longer necessary. Boom. Way simplified. Okay, so now we have this feed pet function. And it does all this stuff to feed your pet. And it all happens inside of the function. What's up, mutants? Ryan says here, hey Venka, do you think a web service could upload your source to HTML every few seconds? Do you think a web service could upload your source to HTML? I'm not sure I understand what you mean, Ryan. What do you mean upload it to HTML? Oh, you mean just have it be on a web page? Every few seconds? You wouldn't really need to upload it, right? You just need to run the server on your PC and have people download it that way. Yeah, that could be done. I'd have to go to my, my router settings and open up a port to the outside world. But that would be, yeah, that'd be doable. Sig says here, not in the mood. I haven't been in the mood for the past few weeks. I might play a little if we do some stuff, then I'll jump off. Okay, that's fine, Sig. You're welcome to play or not play. We're going to be doing, I guess, some kind of temple tonight. I'm not really sure what that's about. Never really played a temple before. A water temple. But Epilus makes it sound like quite an adventure. Epilus is a pretty capable guy. And if he thinks it's going to be pretty difficult, it might be a little bit of a challenge. That's pretty fun, though, too, right? Makes life more fun when you die. Hopefully Mexi joins us. He's a pretty powerful fighter. So when were we playing Unreal Tournament? Dude, that came up, Mutant. Like, did I find it? Did I buy that game? Did I find it that I own it? Something like that. I'll get back to you, Mutant. I think that I might own Unreal Tournament. I didn't think I did. I think that over the last couple weekends I found it somewhere, and I was like, oh, fuck. Mutant was talking about that game. Ryan says, I was just thinking of something that gets a list of .py files and refreshes them from your HDD. Yeah. Yeah, Ryan. If you want, me and you could do that together over the weekend. As a family unit. Do you have a server? Like on the internet somewhere? Maybe inside a code tag in the browser. Yeah, that makes sense. Elder Guardian is pretty easy for me. Oh, so you fought him before, Signapt. You don't, unfortunately. Okay. Yeah, obviously you don't need to, Ryan. All you can do is you can go to your router settings and open up a port and use your own PC as a server. I do it all the time. But if you had an actual server on the web, that would kind of preclude that necessity, which is kind of nice. But yeah, me and you can talk about that if you want. Message me on Intro to Python, Ryan. We can talk about that later if it would please you. Yeah, I know that you're a very gifted programmer, but don't have a lot of networking experience, if I'm not mistaken, right? That's kind of my specialty is networking stuff. We can talk about how you can get a server written and have that be a way to access Python files over the web. It's not that involved. Okay, so let's do the same thing for play with pet, right? Let's change the play with pet function to not require all these random arguments and not return all these random values. All right, let's just have it take the game state and then change the game state inside of the function. It means replacing a lot of baloney. So let's go back here and get rid of all the arguments. No more arguments now, right? Just one. It needs to know the game state. Okay. So it says here, you know, I'm going to get rid of this part. Just kind of put that there as an example with the pet's toy thing. I'm going to do it down here to get rid of the little test code we wrote with the list with the ball and the biscuit. Not really important. Okay, so down here you can see that our pet activity thing here is a little bit involved. Right? It takes this function, feeds it a bunch of arguments, gets the return values as a tuple, and then breaks that tuple apart into smaller, you know, variables, basically. But now we're going to get rid of all this bullshit and simply say, call this function, give it the game state, let it do its job. Right, let it change the game state now, because we have immutable objects finally for the first time. We have objects that are immutable. I'm going to add this code here, the pooping code, to the feeding function. Makes sense, right? So here's our hunger level. Okay. Here's our pooping code. We're going to say here, oh, it's called pet's hunger, not pet's hunger level. So it's actually called pet's happiness, huh? Not, okay, I see. I'm sorry. I've been saying hunger level and happiness level. My bad. Let's go back here and delete all this stuff. So I have this pet's happiness, not pet's happiness level. Okay, pet's happiness. Got my keys mixed up. Okay, pet's happiness. Pet's happiness. Okay, pet's happiness. Okay, pet's happiness. Happiness. Happy, happy, joy, joy. And then we have this pet's hunger, not a hunger level, but pet's hunger. Okay. Das Poopin' code. Here goes says, I've done the research. The best training room music is indeed Careless Whisper. I don't know what that song is. But have you ever heard the rap from, what was the game? Like, SVC Chaos? You ever heard this song? I don't know. I'll find it for you later and link it to here it goes. Pretty funny. Das Poopin' code, Signapt. Let's go down here to our game state and say here, instead of saying pet's hunger, we don't have that argument anymore. We have the game state, though, as an argument. Game state pet's hunger. Let's change that and access that. It's a George Michael song. I don't think I know that song. If I heard it, I might recognize it. I've already started in my own world, and I've gotten pretty far. Nice. So, Sig, what do you think about playing on an iPad? I feel like that'd be kind of hard for me, but maybe you adapt to it, huh? One of those mega saxophone songs. Huh? That's beautiful. Mega sax. Poop on floor is now a key inside of our game state, not its own thing. Let's see here, game state, pet's hunger. Save a new value to it. There we go. Okay. It makes practicing one-frame links sexy, huh? Sexier than it already was. Okay, so now we have, look how simple this code is now. If pet activity equals feed, then run feed pet game state. If it's play, then run play with pet with the game state. When I play at my desktop, I can play Minecraft on that. Oh, nice. When are you getting it, Signapt? It's going to be nice, I think. It's going to be kind of a luxury to have an actual desktop. Hopefully find you can use it to do all kinds of cool stuff. Here goes Love's training room, huh? I really hate training room. But I think if I weren't a streamer, I would hate it much less. I think a lot of my anxiety with the training room comes from the feeling that when I'm streaming Third Strike, especially, I kind of want to get guys involved. If I were just kind of playing for my own, my own amusement, I probably could get more into the training mode. But I feel kind of like there are guys that want to play. I want to play my guys, and it's just kind of like I don't want to just be here by myself doing training mode when I'm on stream. I want to get things going. And I don't really have a lot of time off stream. So this game state now, right? Pet's happiness. That's what I've heard here. I've heard people like lab streams. I just don't get it personally. So I'm very anxious about it. I might do a poll. I'll do a poll. Would you guys watch me do a stream for, I don't know, like half an hour before we do lobbies where I just try to figure shit out in the lab? Get it in May. Okay. It's a pretty good desktop, he says. Yeah, my birthday's in May, so it'll be like a Vencabot birthday gift, but to Signapt. When's your birthday, Signapt? Weatherman says, I'm learning Python in my coding class. Okay, that's a pretty good language to learn. I think it's a great one for beginners, too. Do you have any questions, Weatherman? Where are you at? Where are you at in your class? Okay, so we have this game state pet's name, okay. It doesn't return any values. Just have it return here. I'm going to say here, if game state pet's hunger is greater than 60, then get the pet's name from the game state. There you go. And save this new value to the game state at the key pet's happiness. Okay, once again, just return. All right. We have this thrown object. We're going to ask the player what they want to throw. That's cool. You throw the thrown object. Awesome. Makes sense. We're going to say here, if a game state pet's happiness. Right, we don't have access to an argument anymore called pet's happiness, but we do have the game state, so we can use that to get this kind of data we need, including the pet's name right here. Okay, it's a pretty long line. I'm actually going to break this line up a little bit using some hanging indents. A hanging indent is when you break a line inside of a parentheses, like this, and you indent it by 8 spaces. That way it's clear that it's not like a function or whatever, or any other kind of code block. Code blocks have 4 spaces indentation, right? So when you see 8, you know that it's a hanging indent, just there to make it not go off the line. What's up, M-Tors? How are you, man? Doing pretty well. Feeling energized, feeling good. Kind of a rough start to the day. Again, social media kind of went crazy this morning. But otherwise feeling great. We got a lot of progress done in this game already. It's already 9/11 though. We're kind of late. I'm almost done though, guys. For today, we'll start playing some Liberal Crime Squad soon, I think. 6 says that thing about talking about Windows 10 Pro, huh? It's the same one that my cousin has, and it's amazing for beginners. Nice. I started a class 2 weeks ago, says Weatherman. Very basic Python stuff, but I don't understand it too much. But it isn't like killing me or anything like that. This is your first time programming, I assume, I am Weatherman, huh? Maybe you're not an experienced programmer at all. It's your first time learning a language? So maybe you're not really struggling with Python stuff so much as maybe the abstract programming type stuff, right? The things that probably apply to all languages. Okay. Here's another case for the hanging indent, right? This kind of triggers my speech impediment. The hanging indent. So this line is really long. It's going way off the side of the screen here. It's kind of hard to read. Look how long that line is. I'm going to use a hanging indent to 1, 2, 3, 4. Add in another 4 spaces there. So it's a hanging indent right there. Here's our plus sign. We're going to break this line right in yaw. Right. There you go. Wagging their tail. Okay. Just a wee bit too long still. I'm going to do it like this. Okay. There we go. Okay, so now we have this, this big old string we're printing off here. It's indented by 8 spaces. That's a hanging indent. Make it a little bit easier to read. First time, it's for my major. Okay, so what's your major, brother, man? Something computer science related? But very interesting. It's very powerful. It's kind of a lot to comprehend at first when you're learning a language for the first time. It's a lot of abstract ideas to understand the way that the computer takes the instructions and stuff, and how to, break it up in terms of, what goes on what line. But once you do, it's very, very empowering. It's awesome. It's an awesome feeling. I see your hands very rarely, Venka. Hand reveal, back and front. It's my fetish. Okay, here we go. I've got hand, hand. All right, how to do this? How about over here? Hand, 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 hand. Right? Do the Macarena. The hand reveal. Okay, so we have this, this statement printing off there. That's fine. Otherwise, print off, the pet's name from the game state. Right, I'm going to use a hanging indent here again. Add in 4 spaces to make it an even 8. There we go. Okay. There we go, guys. So now we have this pet's hunger value that's going to be going up after he plays. That's fine. Let's change that in the game state. And there we go. No more return value. There we go. So now we've used a dictionary to simplify our code quite a bit. Yeah, we have to access things, indirectly now through the game state. That's kind of a drag. It makes these, these fetching a little bit longer looking. But what's kind of cool is that we have these simplified little, loop here. Very simplified type stuff here. Okay, kind of nice, kind of cleaner, a little bit cleaner now. So I'm not sure it's going to work. Let's see if it works, because I changed so much stuff. Right, we haven't tested this today yet. We've been doing a lot of lecturing today, but not a whole lot of testing yet. So let's run the code. I'm sure there's probably going to be a lot of typos here. We changed so much already. Let's see if it runs at all. What's your pet's name? I'll call him Signat. Okay, so poop on floor is not defined. What line? 89 is the line? Let's go find it. Here's 82. Ah, right here. So it says here, if not poop on floor. We don't have a poop on floor variable anymore, right? Instead, we have this game state that has a key, poop on floor, which points to that value. Okay. Right here as well, we have this pet's name value. That's not a thing anymore. It's a very, very long line as well. I might put a hanging indent here. So here's our pet's name. Here's our pet's name. Okay. There you go. I want to put this all together like that. Okay, so let's make this a hanging indent, right? It's a little bit long. A little bit deeper. Like my scroll used to say back in the day. Okay. Likewise, do it right here. I scrolled somewhere weird just now. Do it right here. Use a hanging indent so it doesn't go off the screen there to the far right. There we go. Perfect. Please be sensitive. He just has a pirate hook on each, huh? That'd be funny. Wouldn't it be funny if you guys never saw my hands until years later? Turned out playing 3S with pirate hooks. Sig's no furry, huh? It's okay. You don't gotta be a furry. There is a rubber tip to keep him from marring the keys. Yo, fuck these keys, man. That's what I say. It's a little bit long. I guess I lost my... let's make it a little bit shorter, huh? Do you want to clean, we'll say, the room? And shorten this like so. There you go. Okay, so he's using hanging indents here to make this not go so far to the right. Feet for hands. It's gonna be somebody's fetish. Okay, so let's print that off. That's fine. Okay, what else are we missing here? Game state, pet's name. Again, we don't really have a pet's name anymore. We have a game state with a pet's name. That's fine. Okay. Cleaning. Here's another one. Pet's name. We don't have that. We have a game state, which includes the pet's name. We don't have just a pet's name value anymore. Once again, we don't have a poop on floor value. We have a game state, poop on floor value. Okay. We have dagger. Here's pet's happiness. We don't have that anymore. We also don't have a pet's name anymore. Let's fix this. My hands are small for a man. It pisses me off to see old ladies with bigger hands. Huh? Yo, that'd be an awesome backstory for a Metal Gear Solid villain. Guy with small hands. One day he met an old lady that had bigger hands than him. Drove him insane. Okay. My hands are a little too big for me, huh? Yo, big hands club. Let's change this pet's happiness value from within the game state, right? Not as its own value anymore, but as a value that's a part of the game state. Dictionary. Okay, so let's do another one here. Accessing the pet's name from the dictionary here at the game state. Awesome. And let's do some hang indents here. Over nya. Break a line like nya. There we go. Okay, cool beans. Print a blank line. There's continue. Almost done, guys. Only a few more lines left to change here, then our code should work just fine. You will grow into your hands. Do hands not grow? Pigos has big hands, huh? Pigos is a grown-ass man. It's really cramping who I'll choose for marriage. I won't have taller either. It's immoral. Gotta have a lady that has small hands and she's short. Priorities. Game state. Pet's hunger. Greater than 70. Okay. We have a pet's name. We're accessing from the game state these days. Not just raw. That's cool. Likewise, pet's happiness level. Being accessed from the game state. Not just as a raw variable. Cool beans. Poop on floor, same deal. We have a game state, poop on floor, key. Right? Change happiness the same way. From the game state. Pet's happiness. It's a string now. So before it was a name, right? Before pet's happiness was a name for a variable. Now it's a string that points to that variable as a key. And finally, right here, we have this code for getting the game over. We're going to check the pet's happiness in the game state. Like so. Pet's name from the game state, like so. Do some hang indents, like so. Okay. There you go. Okay. So I think this should work now. We're going to find out the hard way. Pocket size princesses all the way, huh? I'll just put an ad in the paper like it's 1920. Hands do grow. That's why they're too big for me. They're going to keep on growing, dude. I hope they grow faster than your actual body does, Signapt. That'd be crazy. Can you imagine if you were like, you know, like a 30-year-old guy and your hands were like as big as fucking catcher's mitts? That'd be sick. Okay, so let's run this module. Pet's name, we're going to call him Signapt again. We're going to feed our play with Signapt. I want to play with Signapt. He's too hungry to play. He seems kind of hungry. Okay, I want to feed Signapt then. I want to feed him a pear. Yes, I shout to all the pear. He eats the pear and seems kind of down. Okay. Set him the pear, here he goes. So let's feed him. What does he really like? I forgot what he really likes. What's his favorite foods? He likes French fries. Okay. Give him some French fries. Sit up eating pears and shit. Still seems kind of down. Now let's feed him his other favorite food, pie. Now he's in high spirits. Okay, I'm going to feed him another pear. I'm going to feed him like this, and then say I want to feed him a pear. Okay, so shout out to all the pear. Eats the pear, seems in high spirits. This is a lasagna. Let's change that from French fries to lasagna, his favorite food. This won't take effect until we restart the game. There we go. It's a pretty good favorite food. Prithee, say with me, I am, did trap with mine own undying doom of stuffing myself with lasagna every hour. Is that a meme of some kind? That sounds godlike. Yo, lasagna is so godlike. That's a pretty good favorite food. Pretty top tier favorite food. What about you here, Ghost? What's your favorite food? Harlots bearing ankles are most unsavory and unwelcome. I love you guys. So, let's play the stick. Now he's in high spirits. Let's play. I want to play fetch with a stick. Okay, Signapt takes their time retrieving the stick while wagging their tail. Okay, not sure if it has a tail or not. It's a question mark there. Alright, cool. So our game works. He hasn't pooped yet. Let's feed him until he poops. Feed. Give him another pear. Okay, seems ecstatic now. Let's feed him a pear. Okay, he took a massive dump. Now he seems kind of hungry, right? So now every turn he doesn't, I don't clean the poop up, he's going to get more and more sad. What the hell is a squash patty? Is that like a hamburger patty that's like vegan? Made of squash? Excuse me, made of squash? So I can clean up his poop. Let's do that. Oh, there's error here on line 110. This is our last error we're going to have, guys. Line 110. Old typo. We haven't changed yet. Where's line 110 at? Right here. If poop on floor, right? We have this game state. Poop on floor these days. That's the problem. Okay, so before we end the stream, guys, I'm going to point out one strength of lists. We talked about lists as a way to sort of bridge the gap between tuples and dictionaries today, but haven't actually used one yet. I'm going to use one now to clarify our favorite food and hated food things, right? So right now we have a limitation in our code. Go look at this, right? Right now we can only have 2 favorite foods and 1 hated food. We have favorite food 1 and a favorite food 2. And we have a pet hated food just an orange. Right? So we go up here to our code for feeding the pet. We can see here we say, if the pet's food is equal to pet's favorite food 1, or if pet's food is equal to pet's favorite food 2, then make him happier. Right? So basically we only have 2 favorite foods and only 1 hated food. But we learned about lists today, right? And how they can dynamically make use of a sequence of things, including things like favorite foods. That's a perfect example of how to use a list. So instead of having these 2 values, favorite food 1 and favorite food 2, why don't we say here, pet's favorite foods is a value, and make it a list. We have a list now. We're going to say here, lasagna and pie. Give it a follow peculiar penguin, the first. Kind of a cool handle. Kind of reminds me of Katie the Penguin of Doom. It's like a croquette with green onion and squash and fried. That sounds sick. I want to try that. I like lasagna with Pepsi while on a date with Garfield. That definitely sounds like a good way to make Garfield like you. And we're going to have a list here of pet's hated foods. Right? He hates oranges. And he also hates, what's a good food to hate? What's a good food to hate, guys? Aside from oranges. I'm not sure, why do you even hate oranges? Oranges are fucking great. I'm going to hate tofu. Tofu sucks. And, an example from the chat. I can't think of one. Brussels sprouts? Those are fucking godlike, though. Says they're shit, he says. God damn it, Ryan. Crab cakes, what Heroes likes. Okay, we'll do Brussels sprouts. It's a hated food. I don't know what dragon fruit is. Black-eyed peas? Those are kind of whack. I'm going to do Brussels sprouts just for Ryan. We'll add another one. We'll also add black-eyed peas. Okay. So 6 is, I know you're Irish Signop. You love potatoes. I think everybody loves potatoes, though. Hey, what's up, Philip? Just ending the stream here for today, dude. Ending the intro to Python stream. 1, 2, 3, 4. Hanging indents, right, guys? It went too far off the right side of the screen. There's a hanging indent right there. Black-eyed peas are not whack, huh? You fool must have had bad luck. So there's a good tier of black-eyed peas. We just haven't had it yet. Ban Philip right now. Philip says okra. Okra's kind of whack. Okra can be okay, too. I'm going to put it in the hated foods, though. Our pet doesn't like okra. He's not a man of refinement. Okay, so now we have, instead of having these 2 values, pet's favorite food 1 and 2, and pet's hated food, there's only 1, now we have these lists of favorite foods and hated foods. So how are we going to use this, right? Well, let's change our code up here to reflect our change, right? We can say here, if pet's food is equal to the favorite food 1, or if it's favorite food 2, then change his happiness like so, right? If he's eating his favorite food, then make it go up. Well, I can say this. I can say, if it's his favorite food, favorite foods now, right? We can say instead of having 1 and 2, we can have an index, 0 and 1. That's one way to solve our problem. Right, so now we have these lists, right? So this game state, pet favorite foods, right? This key in our dictionary, the game state, points toward a list. Right? We can see that right here. We have this list, right? And the list, you access things by index. We learned that, right? So indexes are numbers. This is 0. This is 1. They go in order. 0, 1, 2, 3. Right? So we can get in my index, sure. That's one way to do it. But we still only have those 2 favorite foods then. Okay, well, fine. I'll say, or pet's food is game state. Pet's favorite foods, the list, at index 2, the third item. right? And so on and so forth, you know, indefinitely. We can add that as many times as we want. Here's a problem, though, guys. A problem we have right away. Let's do this, you know, for a bunch of shit. Right, over and over again. Problem we have right away is that if we have, let's say we don't have 5 items in our list, it's going to crash our game. It's going to try and find an index that does not exist. Right? Our list for favorite foods only has 2 things in it. And our hated foods has 4 things in it. Right? So we have a problem here with these index numbers. They're going too high. Let's get rid of these other ones here. But we don't really know. The cool thing about lists is because they're constantly changing, they are immutable objects, right? They can be changed. We don't really know how many things might be in the list. Right? It might be changing over time. Well, how are we going to write this code then? We're trying to say, if you're feeding him one of his favorite foods, his happiness goes up. One awesome use of lists, guys, is we have access to a new conditional test. Right? Before we've used things like is equal to. Does this equal that? We can say here, you know, is the happiness greater than or equal to 80? Right? We have lots of tests we can do, like, is this greater than this? Is it smaller than this? Is this the same thing? But with lists, we can say this. Watch this shit. Watch how simple this is now. I'm going to say, if pet's food in game state, pet's favorite foods. Wow, that's fucking awesome. Lists are awesome because we have access to this in test. So we can say here, if you typed in, let's say, the word pie, right? Well, is the string pie in the pet's favorite food lists? Well, yes, it is. That returns true. Right? We get the Boolean true back. Okay, so that becomes true. Now this runs here. You know, the happiness goes up. If we typed in, let's say, the word apple, is apple in this list? Well, no, it's not. That's false. Right, as we go down to the next one. So now it's kind of cool. So, excuse me. Now that our hated foods is a list as well, we can say here, if pet's food in game state, pet's hated foods. That's our list, right? So basically now, with that one simple change, we have made our game better insofar as our pet can have any number of favorite foods and hated foods. Any number of them. That's sick, right? That's the power of lists in the palm of our hand. So Signapt says here, what kind of computer do I have, huh? I just use a couple computers, one for gaming on. This is, I'm running 2 right now, in fact. One's running the stream, and one I'm doing the coding on. So one is actually generating the video feed, and one is capturing it and streaming it. They're both alright. One is much better than the other one. So people are eating unfried okra, huh? I've had raw okra. It's not super amazing. Ryan hates who in her talk show. I must have missed that part, huh? How many potatoes does it take to kill an Irish? A lack of, let's say, 0. Okay. The one for gaming? It is... I built it myself. It's a pretty ritzy gaming MOBO with GTI 1080 and some kind of really ritzy AMD 2700. I forgot what the series is called. Whatever the new series is. Yo, Swirly, please don't start shit with Here Goes. He's a very dangerous man when he gets upset. I don't want to see any blood in my chat. Okay, so today we have made some enhancements to our code by making effective use of mutability. Now, we have simplified our functions here, which is awesome. Right? They no longer take a bunch of arguments and return a bunch of data. Now they just take one immutable object and get everything they need from that and change things in it. And furthermore, some of these things use lists as well. So I can use lists to sort of very easily probe for what's inside this list, and in the future, even more powers. Venka, save me. You're the one that started it, man. I can't. Here Goes is going to find you, and he will kill you. So before we call it a night here, guys, I want to demonstrate one more important use of dictionaries, and even more so, how you can use callables, functions, as a piece of data. So here in our notes earlier today, we mentioned that of all of our data types we know, we have callables as well. So these functions we're making, they're not just bits of code to run. We talked before about how every program is data and operations. Functions, when you run them, they operate. but the function itself is a piece of data. I'm going to demonstrate how we can use that to our advantage here with dictionaries. So first, let's make some changes to our code. So instead of saying here, while true, and then break when we have a game over, if you try and quit the game, it breaks, right? If you try to print off some stuff, it breaks. Why don't we instead make a new game state variable? Game state. We're going to say here, you know, taking care of pet. That's going to be true. Right, then we're going to say here, while game state taking care of pet. Right, so as long as that's true, keep on going. But certain things I make that false, right? If I go down here, I can make it false right here if we quit the game. We can say, you know, game state taking care of pet equals false. Right, so at that point we stop taking care of the pet. Awesome. And then we can go down here and say, after the pet bites you, we can say game state taking care of pet equals false. Precious grain. Moving to Nebraska this summer, but I must go to court in order to, huh? That's going to be annoying, but hopefully it ends up being worth it. They are, really they are, on YouTube, guys. YouTube.com/Vencabot Archive. We have 3 whole seasons on YouTube right now. Go watch previous seasons. Episode 1 of every season is brand new programmers. Here's what a program is. Here's how you download Python and install it. Then, of course, episode 6 is more advanced type stuff. Usually in 6 episodes, we make a really cool little game. Starting off very simple, ending up more complex over time. With explanations the whole way, of course. By all means, check it out. Okay, so now we have this new way of ending the game, right? We have this thing where we, instead of saying break out of the game, we say stop taking care of the pet. If that becomes false, you know, at some point, then we exit the game, more or less. So cool beans. So why don't we run this code and make sure it still works? Save it, run it. Pet's name's going to be a swirly. Oops. I'm sorry, I want to have this be underscored. Here's your problem. Save it, run it. What's pet's name? A swirly. Do I feed a place? I'm gonna quit. Okay, so it's game over. Right, there you go. So it ends the game for us. Because this value is no longer true. If we type in the word quit, right? It changes the value for taking care of pet to false. Once that's false, we stop looping, right? The while loop stops, we end up down here, game over. Works pretty well. So now that we've done that, we can change the way that some of these other bits of code work. So we have this play with pet function, right? Why don't we make some new functions called like quit playing? Right? So let's go down here to our quit playing code, copy it, make a new function up here. So my goal here is to make a bunch of functions that all take the same argument. Watch this. I'm going to show you guys what I do here. Be a little bit abstract. Good night, Signap, for now anyway. Thank you for the follow, Neolite. We do Python tutorials here every Friday. By all means, come by and hang out and ask questions if it pleases you. We're about to end the stream here, though. We're going to try and wrap this up real quick. Make a new function here called quit, hang out with pet. And it's, let's put it called put pet to bed, right? Put pet to bed, takes the game state as its only argument, and then it does this stuff here. Let's go, Philip. Minecraft tonight. We're probably play some Liberal Crime Squad first, though. So all this function does, it just prints off a message here, and it changes the taking care of pet game state. Run, Isaac, run. The creeper is too strong. All right, so now we can go down here to our quitting code and change this from being this to being simply, put pet to bed with the game state. Okay. Here's the code for cleaning the floor. Let's go copy this code and move it out of here, and instead move it to its own function. Def clean up poop. Game state. Paste our old code. Should still work more or less because we're using the game state for everything now. Once again, guys, we have to return no values because the actual function itself is making the changes to this actual game state object. It's mutable. So if we have the poop on floor is true, do that. Okay, that's fine. Nothing to clean. Awesome. So we go out here to our code down here and just very simply say, if they want to clean, then just run this function, clean up poop, with the game state object. We have our cheat code here, dagger. Let's go put this up here. Awesome. Make a new function here called def, cheat. Give the game state. Paste a code. Unindent because we're not as deep as we were before. Okay. This hanging indent might not be so needed anymore. Let's just try this. Okay. It is still needed, but not as much. There we go. Okay, so now we have this cheat function as well. If we type in the word dagger, we get this cheat, which is cool. Right. Okay, so I'm going to show you guys why I just did that. So Signap says, did I hear liberal? All right, we'll see you on Minecraft, my dudes. Yeah, good night, Signap. Have a good rest, dude. Always a pleasure. Okay, so now we have simplified our test for what the user typed in versus what we run to be very simple, right? Here's where the user types in some stuff they want to do with their pet, right? Then it says here, if you want to feed them, then run this function with the game state argument. If you want to play with them, then run this function with the game state argument. Okay, do you want to quit? Well, then run this function with the game state argument. Do you want to type in the word clean? If so, then run this function with the game state argument. And finally, if you type in dagger, then run this function with the game state argument. Okay, so I've taken every task in the game, put it into its own function, makes it a lot easier to read. You can very easily find it now and see what all is happening here. So you can very easily see what, if you put them to bed, that's how that works. Want to clean up poop, that's how that works. Right? It's very nice and broken up now. Very clear. They always take the same argument, which is the game state. Very tidy, very uniform. Okay, so what's the advantage of this? Why have I done this? Well, for one thing, it's easier to read, but watch this shit. This is another advantage of using dictionaries. If you think in an abstract sense, what we have right here, I'm going to highlight it, is a bunch of key value pairs, right? It's kind of hard to see if you're not a programmer, but if you think about it, what we're doing here is we're taking a key, the pet's activity, and associating it with a value, the function to run, with the game state argument. Right? We have a key here that's associated with a value. Right? Here's feed, that points to this. Here's play, that points to this. Right? So why not simplify this into a dictionary? Watch how I work. Okay, watch this. We're going to say here, commands equals a dictionary. Feed. The string feed is the key. It points to the value of the callable feed pet. Okay? This is where things get a little bit unusual. Right? I'm trying to warn you guys. So, functions are, like I said earlier, they are, of course, operations. They do stuff, right? But the actual function itself, this is how you call it. Or you call it with the parentheses, right? But the function itself is a piece of data. You know, you can use that, you can move it around, you can give it a different name if you want. It's a piece of data. So by saying I want to associate the key feed as a string with the value this function. So now the word feed inside the dictionary here is associated with this function, feed pet. Same thing with play. Play, that's paired up with play with pet. It's a function. Quit. It's associated with put pet to bed. Okay, I'm going to do a hang indent here. Getting a little bit too long. Okay. We also have cheat, right? So we have clean. Clean is the key, and it's associated with this function, clean up poop. All right. And then we're going to finally say here, cheat is associated with this dagger, right? Dagger is our cheat code, It's associated with a cheat function. There we go. So now we have this dictionary that maps what the user typed in to the function to run. They typed in this, run that. Typed in that, run that. Now that's how I use it, right? Get rid of all this if and if else shit. Fuck that. All of it. I'm gonna fix that later. This last part's gonna get fixed later on. That's fine. Get rid of all that and say here, we have this pet activity that we saved, right? We asked the user for a string. They typed it in. I'm gonna say here, commands, so dictionary, at the key pet activity, and run that as a function. Well, I'm gonna save this. I'm gonna save the function, right? I'm gonna say here, our command equals command. Let's say user command, right? User command equals our commands dictionary. Right. Well, it's kind of unusual, a bad name. Let's just call it like our the command callable, right? Trying to make it clear what it is, right? So we have this commands dictionary, right? We have the commands dictionary, and we are feeding it not the string pet activity, but rather whatever the user typed in here. Right? They typed in, clean. Right? This became clean, right? The input value comes back as clean. We're saying, look at the dictionary here, commands. Here's a dictionary, right? Find the key, clean. There it is. And save that value as command callable. Here that is. Clean up poop. Then we're going to say here, use the command callable, call it with the game state argument. Okay, that's where things get a little bit frisky, a little bit exciting, right? So what we've done here is we replaced this big if, elif, 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 elif sequence of code blocks with this dictionary that simply takes a command string that the user might type in and associates that with a function to call if they typed in that string, right? And here we're saying, get that callable, get that function out of the dictionary by feeding it the key of what they typed in. So if they typed in the word clean, use that as the key, and we're gonna get back clean up poop as our command callable. This is what we're calling it. We call it anything we want to do, right? Then we're gonna use that callable we got back, and we're going to feed it the game state, because all of our functions here take the game state. That's why it's so interesting that we made them all take the same argument, because now they can be swapped in and out for each other, right? No matter what they typed in, no matter what command we got back, no matter what callable we got back, we know it takes the game state as an argument, and we know that it returns no values, because all of our functions up here take the same argument and return no values. So we can kind of swap them in and out for each other right here. Right? So by using mutability, in this case a dictionary, we have sort of really streamlined our program. Right? We made all of our functions easier to read because they take fewer arguments and return fewer stuff, and return fewer values, in this case nothing. And now we can even get rid of that big if, elif block using this dictionary here. What's up, Garchuals? How are you passing the game state to these callables as an argument? But here's our game state right here. It's a dictionary. Right? It gives it a dictionary. It contains keys for all of the important aspects of our game. Right? Now, I'm not sure what your skill level is, Garchuals. Your first thought might be, why not use a class and an object? But we haven't learned that yet. We're going to learn that probably on next stream. But we're beginners here. We just learned about dictionaries for the first time today, and we're using mutability to consolidate our entire state of the game into one object, whereas before it was a long sequence of variables. Right? Now, instead of being a bunch of variables, they're all just living inside of this game state dictionary. And we're passing that object as the argument to these functions. So now these functions not only can read these arguments, but also change them. Because, that's the advantage of mutability in our code. So let's run our code, make sure it works. It might not. I changed a lot of stuff here. We're going to play a different game here, guys. Run module. Pet's name. I'll make him Garchuals. Kind of a cool name. Do you want to feed or play with Garchuals? Okay, so here's the test, guys, right? Our code just got down to this part, where it's asking us here for a pet activity. It's going to save. Whatever we type in gets saved, right? Then whatever we type in is saved as this, this variable, pet activity, and it's used as the key in this commands dictionary, right? So if I type in the word feed, it should use that as the key for the dictionary and get me back the feed pet function, right? Then that function is going to be called with the game state. Let's see if it works. Type in the word feed. It worked. It said, what do you want to feed Garchools? So what happened here was, I typed in the word feed. It got saved as pet activity. Right? Then we're saying here, use the commands dictionary that we made up here. Right? Use it right here, and get the value out that is at the location, at the key of whatever the user typed in, and save that value as our command callable. So I typed in the word feed, and we got out this function, feed pet. Okay, so now we have this feed pet function saved right here under this name. Then we call that function, as we always do, with parentheses and an argument, in this case the game state argument, and we get this feed function that runs, right? We can feed the pet, we can feed Garchwool some okra. He hates it though. He may kill us actually. I don't want to do that. I don't want to die right away. Let's feed him some lasagna. He likes that. There he goes. He's in high spirits. Now I can play with him, right? So everything works the same way that it always did. It's just that we got rid of that big if, elif block by using a dictionary, because really we abstracted it so much that we saw that what we had was a case for a dictionary, right? We saw that we had a string that was associated with a function. It was written out at the time as a bunch of if blocks, but what we saw was that we really had a key and a value for that key, which was the function to run, right? So we actually converted that into a dictionary. Look at the follow Garchools. We do Python tutorials here every Friday. We're a variety stream, guys. We play a lot of games here. It's a Third Strike, a little bit of Fear, Minecraft, etc., etc., etc. It's a variety stream. But on Friday, guys, on this time slot, it's always Python tutorial. By all means, come back again and hang out with us. So we're going to end the stream here, guys, with a conundrum. Going to end it on a sad note, guys. Let's all cry together. By using this new method I have here, right, our new system here of calling commands, if I type in the word poop, which is not a command we recognize, our old code, if, elif, else, would have said, hey, listen, bro, you triggered my else block, and I need to ask you to punch in a command I recognize, right? But now what we're doing instead, if I type in the word poop and press enter, we're going to be giving poop as a key for the dictionary here. As you can see, there is no key called poop here. We have feed, we have play, we have quit, we have clean, and we have dagger. So what if I type in poop, what happens? Oh, fuck. It crashed the program. It says key error, poop. There is no key called poop. Right? So in some respects, our game has become simplified, and in others, we have broken it. Right? Our game has lost functionality. Now it will not correct us if we put in the wrong command, and it will crash on us. There's a few ways to fix that. I'll fix one right now, in fact. I'm going to go right here and say, fix it like this. We'll say if, pet activity, where it was typed in by the user, not in commands. Then print off, please type, a command. Please type will say, feed, play, quit, or clean. Right. There, problem solved. Continue. Right. That goes back to the top of the loop again, ask you for another command. So that's one way to solve it. Right. So I take back what I said about ending on a sour note. We ended on a positive note, right? So we're going to say here, if you type in a command, we can say, well, make sure that that command is in our dictionary. If it's not, well, then we can make an error message, right? Let's run it again. Run it. Pet's name. Garchools. I want to poop. It says, please type in feed, play, quit, or clean. Okay, so we solved our problem. Game over. Easy. But I also want to solve this problem in another way next time that involves error catching. So in Python, if your program crashes, it's not the end of the world. You can actually see it about to crash, and then stop it from crashing, and then actually use that to your advantage. Say, well, why do you want to crash? If I can find out why you wanted to crash, I may be able to actually use that effectively. I'm actually going to program it in right now. Let's get rid of this. I'll explain how it works later. I'm going to say here, try this. Then accept key error. And say print please type either feed, play, quit, or clean. Okay, so we're going to explain how that works next time, guys, but basically, we saw it try to crash. We tried this, we typed in the word poop. It was going to crash with a key error. We said, hey, instead of crashing with key error, do this instead. We're going to talk more about that next time. Guys, as usual, if you guys enjoy the show, check out Patreon, patreon.com/Vencabot. Even $1 is a huge help. I stream for 40 hours a week, every week, and it's a lot of work. It's a lot of time. When the stream ends, we're going to stream all night long, doing things like YouTube. It's kind of like my whole life here. It's kind of exhausting sometimes, but your guys' support on Patreon and through Twitch subs, etc., makes it possible. Makes it possible. Thank you, guys. Also, if you're like me, maybe you're totally broke, you enjoy the show a lot, maybe you're a student, or you're a part-time employee, or maybe you're working full-time, but you have a house to pay off and a family to feed, and just, you know, helping a streamer out financially is not really in the cards for you. I understand, man. That's kind of like my life, too. There are streams I enjoy, and I'd love to support financially, like Scrub Series, Tron Swanson, that I really can't afford to support as much as I would like. That's great, because the best way to help out is free. You know, get in the chat, come say hi, come hang out, ask questions, be a part of the show, make my life easier as a host. You can have somebody to kind of talk to while I'm streaming. That's a great way to help out. You can also help out by you know, following on Twitch, tell your friends we're here, spread the word, save clips. Check out YouTube at youtube.com/Vencabot archive. I have all my past streams archived there in 1080p 60 frames, including 3 whole seasons of Intro to Python. Yo, thank you, Tron Swanson, for that Twitch Prime sub. That goes a long, long way. But yeah, we have 3 whole seasons already of this show, you know, completed, which is, you know, there are 6 episodes each, and they start off with, you know, what is a program? How do I download and install Python? What is Python? Right, very, very basics of your first time ever programming ever. And then throughout each episode, we add in new ideas and learn new stuff and make our program even cooler. You know, season 1 was a Pokemon game, where on the first day we had a, you know, a Pokemon game kind of working like a Pokemon battle, but it was very simple and very basic. In episode 6, we had a really cool Pokemon game where you could actually fight and make your own monsters, make your own moves and stuff. That was sick. Season 2 was our Zork clone, which is sort of like a textual adventure game. It started off very simple on episode 1, and then by episode 6, it was a really cool little puzzle adventure. We would walk around a cave and explore and unlock doors and stuff. Then season 3 was our RPG kind of like Dragon Warrior, where you would fight monsters, collect gold, spend that gold on buying new items and stuff. That was kind of fun. This is season 4, guys, the virtual pet. Episode 1, again, was very, very basic. Now we're getting into some more complex stuff like immutability and dictionaries. But if you guys have been following along the whole time, you're going to probably, you know, be more or less up to speed. If you're not up to speed, though, check it out on YouTube again. We have a playlist there. It's called Intro to Python. Garchwell says, what's the nice thing you've ever done using Python? I'm going to reserve that answer, Garchwell, because I have a pretty awesome piece of software in the works right now that I'm going to be pretty proud of, I think, very soon. I'd say for now, maybe my current rig, my streaming rig. My break screen is all fully programmed by me, which is kind of cool. As a streamer, I find that being able to program is very empowering. In fact, many aspects of your life as a programmer are very empowering. It's a lot of fun creatively. It can make you, you know, more efficient at getting things done in your life. I think that programming, especially in Python, is very, very cool. In any case, guys, sorry about the rant. I'm going to go a very short break, come right back with some liberal crime squad, play some text-based adventure games. It's going to be a lot of fun, I think. I will see you guys very shortly with that. Peace out for now. Every Friday, guys, we do Intro to Python here. We're a variety stream. We do a lot of gameplay here with the Street Fighter 3 Third Strike and other cool games. I put a lot of you know, love and care into every show we do here. On Fridays, it is Intro to Python here from around 6 to around 8 p.m. Eastern. Excuse me, from around 6 to around 9 p.m. Eastern. We had a late start today. We're ending late. We started an hour late. We streamed an hour late. We got a lot done, though. But come back next Friday, guys, around that same time slot to see how this shapes up for episode 5, which is going to be things such as probably more work with lists, add some new features to our game, and maybe even gradually introduce the idea of classes and instantiation, objects, etc. You guys see that? Someone clip that salt, that's going to be quite a big change, though. What the fuck? The week after that, guys, episode 6, last episode of the season, we're going to have probably a much cooler game by then for playing with our virtual pet. But we've been learning a lot, I feel like. Coming up here very shortly, guys, like I said, it's going to be Liberal Crime Squad. It's a really cool text-based game I'm a big fan of. It's going to kind of hang out very casually and play this game. Probably shoot a bunch of guys, steal some stuff. It's sort of like Grand Theft Auto meets like Jagged Alliance, but all in text. It's kind of crazy and a lot of fun, I feel like. Maybe not the most bombastic game to stream, but c'est la vie. Thank you for the follow, by the way. Twisted Aphid. Very cool handle. What I find is that a lot of guys on Twitch have really cool names. feel like a broken record sometimes saying, oh, that's a really cool name. Nice name. Awesome handle, bro.
Goose.
But a lot of them are really cool.
So, like, I intentionally didn't do super because I... God damn, that shit was...
I wonder if Twisted Aphid is a gardener. Because aphids can be a bitch.